Hello everyone present here. I would like to welcome you all for the IITNSC 100 Hours Techno Carnival by IEA Tiruvallur Local Center on the topic Seminar on Sustainable Development Smart Cities. I would like to welcome our chief guest, Dr. J. Balamurgan sir, MIE Honorable Secretary of IIA Tiruvallur Local Center. And I also welcome our everyone present here. I would like to welcome IITNSC 100 Hours Techno Carnival by IEA Tiruvallur Local Center on the topic Seminar on Sustainable Development Smart Cities. I would like, and I also welcome our speakers, B. Saravakumar sir, Assistant Professor, Guru Nanak Institution, Technical Campus Research Scholar of Dr. MGR Educational and Research Institute, and P. Kanaraj Research Scholar, Dr. MGR Educational and Research Institute, and P. Elila Risi ma'am, Research Scholar, Dr. MGR Educational and Research Institute, and P. S. Mahita ma'am, Research Scholar, Dr. MGR Educational and Research Institute. And I also welcome all our participants for this grand occasion. First, I will call our chief guest, Dr. J. Balamurgan sir, the Honorable Secretary of IIA Tiruvallur Local Center, to give a welcome speech.
Thank you so much, Hari. So it was a wonderful day, and we are about to go ahead with our 100 hours centenary program. So it is going to be the eye opener for all such engineers that we are going to throw away the technology of lot of information is going to be connected because of this 100 hours of journey, that different engineers are polling themselves on different technologies to make sure that this 100-year, which is being celebrated by Tamil Nadu State Center, so which is first of its kind program, so that is going to portray all such technologies on sustainable world. So sustainability is something like whenever an engineering practice accidentally or incidentally we may land up with a technology means, so it is a technology that need to groom the particular engineering field, and also it need to be, give some solutions. So normally when we can take up an engineering, say for example, when there was a copper plant, so it is a good opportunity that the copper cost come down to a lesser level when it is not imported. So later part, what happened, the sustainability was not there, then it was closed in India. So in such case, we need to have a technology which need to be very sustainable, and it is also not harming any such people. So that is very much important. In that aspect, we have taken a lot of measures, and we need to ensure that the sustainability is retained with all such engineers, and the technology is also sustainable, so that the people can enjoy the technology which is not hurting them or hurting the environment. So it is not harmful. So in such aspect, so the 100 hours has been planned, and all the 15 local centers which is put up in Tamil Nadu has catched up, and they have done with the such programs, and it has been exorbitantly executed by all such center. And people also welcome such moves, and right now it is a good opportunity that we are about to have another 5 hours of program by our PhD scholars, so who are pursuing their doctorate. So they are about to give their own presentation on sustainable world. So I welcome all the participants, and I wish you all the best for such a task they have taken up in putting themselves into the technology wing, and also they are going to portray the technology to the common public. So hats off to you. So all the very best. Thank you.
Thank you, Balamurgan sir, for sharing your thoughts on the sustainable development of goals. Next, I would like to welcome B. Saravakumar sir to speak about the topic on role of BESS in smart cities, to share his valuable thoughts with us.
Madam, thank you, madam. So myself, Shravan Kumar. I hope I'm audible to all of you. Hello.
Yeah, you are audible, sir.
Thank you, ma'am. So I'll just present my screen. Yes. So I hope you are able to see my screen, madam.
Yes, sir, you can see.
Yeah. So myself, Shravan Kumar, I'm working as assistant professor at Guru Nanak Institution's Technical Campus, Hyderabad. I'm also a research scholar at Dr. MGR Educational Research Institute, Chennai. So my title of today presentation is role of battery energy storage system. That's called BESS in smart cities. Okay. Just one second. Just one second, madam. Yes. Elil ma'am. Hello.
Yes, sir. Yes, sir.
Madam, actually, I'm not able to move in the PPTs. I'm not able to go like scroll it down. I'm first time using Zoom. Can you please help me out?
Sir, you just work it on PPT, sir. It will reflect it on Zoom. Nothing new, sir. You just work it on PPT.
Yeah. First, like I'm sharing my screen.
Then slideshow. Go for slideshow.
Just 1 minute. Madam.
Mhm.
Yeah, I'm trying to share my entire screen, right?
Yeah, you can do that also.
Yeah,
Entire
entire screen. Yeah, entire screen I have shared. So this is my screen, and then I'm clicking this slideshow.
Slideshow.
Then when
Yeah.
I click now it's working.
Yeah.
Okay.
Mm.
Yeah. Fine. So. Share. No, ma'am. Again, it got stopped actually. Fine. Then I will explain like this one by one. Okay. Yes, fine. So when it comes to smart cities, so we should remember that everything is interconnected through fog and edge computing. So you people are very familiar with fog and edge computing, right? So in IoT, we have the terminology, the fog computing and edge computing. So I hope there are some students here. Hello. So ma'am, only students are also there, madam.
Sir.
Even students are have joined.
Yes, sir. When only students are there. So based on that, you can move forward with that.
Yes, yes,
The
yes.
talk with the students.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. So in smart cities, most important thing is you're all familiar with fog and edge computing. Like edge computing takes place very near to the sensors, and fog computing takes place near to the cloud. So in smart cities, all of these things are interconnected. Fine. So you can see this. So this you can see the renewable energy sources like wind. Like here you have wind turbines, and then you have solar panels, and you have industries and cities. So all these things are interconnected in smart cities, right? So now this is another example how all these renewable energy sources are interconnected. Fine. So you can see here the buildings, the housing structures, and the industries are interconnected with renewable energy sources, not only renewable energy sources, also with fossil fuel sources. So now coming back to my research. So my research is all about the battery energy storage systems. Okay. So how this battery energy storage systems are linked to the smart cities. So most important thing is battery energy storage systems. Basically, we know that they will just store the energy. Either it may be from renewable energy sources like solar or wind, or from fossil fuels, and then it's going to be released when we need it the most. That's when the customers require the most. This energy will be released from the battery energy storage systems. Now, so this is basic applications like where we can use battery energy storage systems. They can be used in power stations, they can be used in transmission lines, they can be used in substations, they can be used in utility grids or industrial solutions or residential use, commercial use, or even transportation. But when it comes to actual power system applications of battery and storage system. It's not only that battery is all about storing. So we know that batteries are used to store electric energy, but not only that, batteries can be used for some other purposes as well, especially in power system applications. So if you see here, you can see my slide, like you have load leveling, you have peak shaving. So what is the meaning of load leveling? And that we'll discuss in the next slides. So these are the applications of battery and storage systems in power systems, like load leveling and peak shaving. And from it can help us from black start. So whenever there is a black start, the battery energy storage system can help us. It's not only that, it will help us in power quality enhancement and power reliability. And also it will help us in frequency regulation. So my research work is basically about frequency regulation, how I'm going to use the battery energy storage systems to regulate the frequencies. So we all know that in smart cities, in the previous slides I have shown you. So I've shown you in the previous slides that renewable energy sources are integrated. In smart cities, renewable energy sources are integrated with not only residential as well as industrial. But when you try to integrate renewable energy sources with power systems, definitely because of its intermittent power, there is going to be frequency deviations. Also, there will be voltage fluctuations. Okay, so in order to reduce this deviations in frequencies, and in order to reduce the deviations in voltage, so I'm trying to use battery energy storage systems to make the deviations null. So that is my research work. Okay, so what is we have to know that battery storage systems also has got multifunctionality. It's not only about storage, but it's got multifunctionality. It can be used for frequency regulations. It can be used for reducing frequency regulations. Also, it can be used for reducing voltage regulations. Also, it can be used for load leveling, peak shaving, and different type of applications in power systems. Right. Now, so let me get into the introduction. We'll see the introduction. So in order to fulfill the growing demands for energy, in order to fulfill the growing demand for energy, there has been a rapid expansion of renewable energy sources such as wind power, solar in recent years. So students and friends, we all know that the cities are growing rapidly, the population are growing rapidly, and similarly, the city is also expanding rapidly, and we are running short of fossil fuels, right? So currently, we are even in India, the most of the energy we get it from fossil fuels, that is from coal-fired power stations. But in next 30 to 40 years, they are going to deplete. That the fossil fuels are going to get exhausted, and it's compulsory that we have to shift to the wind and solar power as much as possible. Okay, so for that, renewable energy sources are rapidly emerging and showing significant value in the entire energy system, with advantages of less pollution, sustainability, and reducing the cost of mitigating climate change. Okay, so it's a compulsion for us that we have to shift to renewable energy sources, since the fossil fuels are coming to an end. But at the same time, there is an issue with renewable energy sources. Just now I've discussed, like for wind, there is an issue that the wind energy is intermittent, and as well as for solar also, there is an issue that solar energy is also intermittent. And when you have this type of intermittent supplies, definitely there will be a fluctuations in frequencies. Okay, so if there is a fluctuation in frequency, so what is going to be the effect? Like any one of the students can just tell, like if there is a fluctuation in frequency, then what type of effect you can feel? Yeah, excuse me. Hello. Yes, like whenever there is some fluctuation in frequency, so what type of effect you can like what type of effect will happen on the power supply, or what type of effect will be on your loads? Okay, so I'll just tell you, like if there is a frequency deviations because of these intermittent renewable energy sources, definitely your motor may run at more speed. Whatever the electrical appliances you are using may run at more speed. So similarly, if there is some voltage deviations, so your equipments may get spoiled. So always we have to make sure that there is a minimum voltage deviations and minimum frequency deviations. Okay. So my research was all about how I can use a battery, how I can use a battery and connect to these renewable energy sources. So whenever there is an intermittent supply, the battery should be able to make sure that the frequency deviations are being minimized and voltage deviations are being minimized. Okay, so that was my research work. Now, just 1 second. Just, yeah, got it in the next slide. So when the distributed generation of renewable energy is integrated to the grid, so voltage and frequency of the grid will fluctuate due to this intermittent output of distributed generation. Distributed generation means it's nothing but the wind and solar. Okay, so the voltage exceeds the allowable range, then electrical equipment will operate at an over voltage or under voltage, which will cause the insulation to fail or insulation to age up, causing the power loss in the distribution and may result in the voltage collapse or partial grid collapse. So similarly, if the frequency deviation, also there is a frequency deviation, then we can see that the speed and the power of the motors will result in a change in the output of the transmission machinery, and also it will affect the production efficiency, as I have discussed. Okay, so now the change of the loads operating system can provide a frequency regulation when the system frequency fluctuates. Now, initially, there are some traditional methods. So before battery, so before my research, before I started research, before some 15, 20 years before, so how these how this frequency deviations or how these voltage deviations was being maintained. So initially what these people did is the change of loads operating power. So in order to make sure the frequency deviations are less, they try to change the loads operating power. Okay, so the change of loads operating power can provide frequency regulation service when the system frequency fluctuates. Okay, next, on-load tap changer, OTLC, and step voltage regulators and shunt capacitors were used. So these were used to try to reduce this frequency deviations or voltage deviations. Next, traditionally, traditional generators droop control method. So this is one of the method used to address the frequency issues in the power system. But this droop control method is only used for the fossil fuels. Okay, it's only used for the fossil fuels. This method is not applicable for the renewable energy sources. And this on-tap load charger and step voltage regulator shunt capacitor. So these methods, there was a drawback. Like once you have more number of renewable energy sources and more number of fossil fuel sources connected to the grid, so these methods were not able to reduce those frequency deviations. So this was the reason why I started my research on a battery energy storage system. Okay, so existing methods were not able to provide were not able to reduce the frequency deviations, and that is the reason I did research on battery energy storage systems. Now, so in order to solve the shortcomings of traditional regulation methods, we have proposed many solutions using battery energy storage systems to adjust voltage and frequency recently. So BSS battery energy storage system with fast dynamic response characteristics can maintain power balance in the grid. Okay, so that's an advantage with battery energy storage systems. With its dynamic and fast response characteristic, so we will be able to maintain the power balance in the grid. Now, so this was my actually survey questions. So before I started research, under the guidance of Ramesh sir, so I have made one survey, and I have sent this form to industrialists who is working in battery energy sector, and also to accommodations. So normally, which type of battery energy storage system is used? So we know that even in my house, my own mobile phone is running on lithium-ion. So maximum, most of them are using lithium-ion, and even in the BSS also, in battery energy storage system, currently research in microgrid also, we are using lithium-ion itself. Okay? But lithium-ion, even though it's very good, nowadays it's even explosive. We have seen many accidents with lithium-ion. Fine. So which type of battery energy storage system is used? So 80% of them answered lithium-ion batteries, and remaining nickel-cadmium batteries and lithium iron phosphate batteries. So name the method which is used to estimate the SOC of batteries while charging and discharging. So the different methods are there. These are the two methods that the researchers have answered: constant current discharge method and Coulomb counting method. So SOC, state of charge. So state of charge is a very important thing whenever we're dealing with battery energy storage systems. SOC becomes very important, state of charge. So if you are trying to operate in an optimal SOC range level, only then the batteries come up to a larger level. Even with respect to your batteries, your mobile batteries also, if you are operating the mobile batteries within the prescribed SOC level. Means you should not discharge our batteries to less than 10% or less than 20%. If you do it quite often, then your battery will not last more than 6 months. But if you keep a particular SOC level, then battery will work for more time. So were you able to coordinate different battery energy storage systems? So around 60 of them answered no, only 40%. So battery coordination is very important. In our smart cities, there will be different smart grids interconnected. So there should be some coordination between different batteries. And if you're able to coordinate batteries, in my research, what I have seen is, if I was able to coordinate batteries, only then I'm able to reduce the frequency regulations better than non-coordination. So if there is an individual batteries acting, then the frequency regulations was very less. But when there was a coordination of battery storage systems, then the frequency regulation was minimized to very small level. And even the voltage regulations, voltage deviations was also minimized to a very small level. So coordination played a very important role. So this was before my research. It answered 60% of them answered like there's no coordination, and 40% answered yes. But coordination is a very new topic which is currently there. So in my through simulation, I have shown that whenever there is a coordination, that frequency regulation has been very much minimized. So this is my next survey question. So which of the following functions were performed by battery energy storage systems? So most of them have answered this: frequency regulation and low voltage, right to support, output smoothing, time shifting, oscillation damping, load leveling, active and reactive power management. So like this is my answer. Frequency regulation up to 50%, load level right to support 50%. So most of the researchers currently are doing frequency regulation with battery energy storage systems. Next, which type of strategy was used for coordinating battery energy storage system? So there are different things like central controller and distributed controller. In my research, I'm using distributed control strategy. Fine. So different type of algorithms were used. Some of them answered a fuzzy logic algorithm. Even I have used fuzzy logic algorithm for coordination of battery energy storage systems. Next, which type of frequency control was performed by battery energy storage system for maintaining frequency regulation? That's primary frequency control. So primary frequency control is the initial control. So maximum in all over the world, primary and secondary frequency controls are used. One second. Yeah. Next. Yeah. Which type of frequency strategies were used for frequency regulation by battery energy storage system? So most of them answered like the droop control method. But there is an issue with the droop control method. Droop control method is normally used for traditional power systems like the coal-fired power stations. And when it comes to renewable energy sources, the droop control method drastically fails. So these were my another questions. Like if any combined strategies were used, then they answered no. And most of them face the challenges. Like what are the challenges faced during coordination? They said charging and discharging issues. So which I have tried to reduce the number of cycles. In my research, during this 4 years of research, I tried to also reduce the number of charging and discharging cycles. So was dual battery. Some people have used even dual battery energy storage systems, like 2 battery storage systems in parallel for optimal dispatch of power. Yeah. Now coming to my research work. So after I have after I have noted my value, after I have given these questions, after I have given my survey questions, and once I have received all the inputs from different researchers, then I have formulated my work. So my actual research work was like the proposed. I wanted to propose a coordination control algorithm which first calculates the required power for voltage and frequency deviation control, and then compares the different values and obtains an optimal regulating power for simultaneously solving voltage and frequency deviations, and also reducing the number of BSS and charging and discharging cycles, and improving the lifetime of the batteries. So this was my work. So my work was basically to reduce this frequency deviations and voltage deviations, and to also to increase the lifetime of batteries, and to reduce the number of charging and discharging cycle. So this was actual work, and I've divided into 3 different objectives. Like the first objective is to reduce the voltage and frequency deviations, and second and third objective was basically about how to reduce the number of charging and discharging cycles. So if any of the students are there, you are free to ask me questions, like how I started my research work. So initially, it was about like why there was the fluctuations in the battery. I explained you what is the reason behind fluctuations in the battery, and what happens if there is a fluctuations in the microgrid, and then why there is a fluctuations in the voltage. If there is fluctuations in the voltage, what will be the result? And to reduce this voltage and frequency deviations, I have used battery energy storage systems. Now, next slide. Fine. So for BESS, the main limiting factors for BESS is state of charge and rate of charge and rate of discharge. So these are the 3 constraints I have used. Like I have always added these 3 things as a limiting constraints for battery energy storage systems. Like what is the, I've added this SOC, like it should, my BESS should operate in the prescribed, only in the prescribed SOC level, and the rate of charging should be less than a particular range, and rate of discharge. So these 3 factors I have considered for battery energy storage system. Yes, so you can see this slide. So this is SOC. So this is a normal SOC. So before my research, most of the papers concentrated like this. So this was a traditional method. So after doing my research and observing many papers, so I've come to a conclusion that BESS should be operated only in this optimal area. Only in this optimal area. So if you try to operate BESS in these areas, forbidden areas, like only up to here, you're trying to use your battery only up to here. That's also not a good thing. Your battery will have very less time. If you want a battery to have more time, if you want your battery to work for more number of hours or more number of days, then you have to make sure you operate it in the optimal SOC level. This is the optimal SOC level. Okay. Yeah, this slide is just an example of showing how all the batteries are connected. Okay, so not only you have your different renewable energy sources. So wind power is there, tidal is there, and EV vehicles, nowadays plug-in electric vehicles, plug-in vehicles. So all these battery energy storage systems, in my research, I'm going to interconnect all of them, and using an algorithm. So I'm going to make sure whenever there are some frequency deviations or where are some voltage deviations, I'll try to minimize them with the help of battery. So this is my research work. Okay, fine. This was a previous algorithm. So before my research, I have seen some papers. So this was algorithm, the way they have done. Okay, but the previously researchers, they didn't concentrate on SOC level. The algorithm was simply like this, like start frequency regulation and calculate frequency regulation of the grid. If the frequency is greater than 50 Hz, and try to minimize, and then if it's equal to 50, then go for the next process. But in my research work, so I have done like this. So I have considered the SOC level. Okay, this was the main thing. So in my research work, I have considered the SOC, state of charge level. So in the previous slide, I have shown you the importance of SOC. So if you're trying to operate your BESS in the optimal SOC level, so only then you will get more life, like the BESS will be more life, and the number of charging and discharging cycles will also be less. So this was my flow chart. Next. So before I implemented my MATLAB model, I have done some research. So this was one of my base paper. Okay. So in this base paper, there are different locations. Okay. So I have shown you here locations. Okay. Like location 1, location 2, location 3. So similarly, so here there are some 11 locations. So for 11 locations, this guy, this man, Sion John Lee, he has actually used algorithm for coordinate, like he's used algorithm for batteries, and he has clearly shown if it's uncoordinated, if the different battery sources, battery sources or storage systems are uncoordinated, then the frequency deviations are up to 0.61. The frequency deviation 0.61. But if you do the coordination, if you try to coordinate different battery and storage systems, then you can, he has clearly shown that frequency deviations has been minimized. So it's drastically reduced, no? 0.6 to 0.04. Okay, so So initially, part of my research, I found out that battery energy storage system can be used to reduce voltage deviations and frequency deviations. And then upon doing after one and a half year after my literature survey, then I also have understood that by using coordination, you can even reduce it further. The frequency deviations can be reduced even further, like you can see. This is 0.6, and this person Lee, this guy name is Senjong Lee. So he reduced the frequency deviations to 0.042. There's a lot of frequency deviations reduced because of coordination. Okay. Fine. So after this paper, I understood the importance of coordination, and I have used different algorithms to make sure different fuzzy algorithms to make sure that the frequency deviations are being still minimized with the help of coordination. Okay. Slide. So this was my base research paper, like frequency curve obtained using uncoordinated control scheme and frequency curve obtained using coordinated control scheme. So you can see here, the frequency deviations are almost reduced. Similarly, the voltage deviations are almost reduced, and see the huge change in the charging and discharging cycles. So your mobile phone also, if you have less charging and less discharging cycles, then you can expect your mobile phone to last more time. So you can see the coordinated control. So using coordinated control, the number of charging and discharging cycles have drastically reduced. Fine. Next. So this was one of the projects which in MATLAB I have implemented this. So this is for different times. There are some changes in the load, like at 5, 203 load in kilowatt, 203 kilowatt, and at 10 the load is 518. So load is keeping on changing for different time values. So for this, I try to implement like the importance of battery. Now this is peak shaving applications. So instead of getting this peak loads, so if you use battery, the battery is going to consume most of the loads. So it's going to reduce that peak shaving application. So initially in my third slide, I showed you the battery and storage system applications. I told you peak shaving. So what is the meaning of peak shaving? So whenever you have a high amount of loads for a particular duration, so those things can be peak shaved with the help of battery. So you see these two have been peak shaved with the help of battery. So battery is taking these two loads. So I have implemented this in MATLAB, and similarly load shifting application. Okay. So load shifting application. So here you can see the load is more from 7, like here it is 7. From 7 to 17, the load is more. So battery has taken all the loads and it's reduced. Load shifting applications. Okay. So you can shift the loads. And load leveling application. So this is a load leveling application which I have implemented in MATLAB. Next, system frequency. So this is system frequency. So this was in my research paper, like without wind turbine BSS control. So first one is wind turbine BSS control. Second one is only BSS control, only wind or wind control. Okay. So what you can observe here, if there is only wind is used for controlling frequency deviations, then you can see the deviation is much higher. Now only BSS is used, even then the frequency is much higher. But if you use a coordination, if you try to coordinate, either it may be between battery to battery or between battery and wind turbine, then the frequency deviations are much reduced. So this is a blue line. The blue line is coordination between wind as well as battery energy storage system, blue line. So what you can clearly observe is the deviation is much lesser. So this is the main reason why I went for coordination between battery and wind. So whenever we go for coordination between battery and wind, the frequency deviations are much reduced. And if you do it individually, of course, individually BSS can also control the deviations, but unfortunately the deviations will be much higher if it's done individually. Yes. And this is another example, like number of charging and discharging cycles. So you can clearly see here. Oh, excuse me. Yes. So this one. So this is. So this was this was the previous papers 2312, and this was my paper 1597. So this is the discharge cycle. So you can clearly see the differences. How much is the difference? like it's only 3470. It's taking the 3470 cycles for according to this power. If it's 7000, so discharge cycles are 7130 previously, and now it's 3470. Okay. So number of charging and discharging cycles have been reduced. Yeah. Yeah. Fine. Similarly, the charging power also is drastically reduced with the help of coordination. This is another. This is my actual research. So where you can see. So this is before and after. The blue color indicates after coordination. So after coordination, you can see there's much. The fluctuations have been much reduced. So before coordination, before coordinating this wind turbines or batteries, you can see the frequency deviations are much higher. You can clearly observe the frequency deviations are much higher. Right? The frequency deviations are much higher, but whenever there is coordination, the frequency deviations are much less. So this is with respect to voltage. This is before. This is same. This was a previous one. This is before and this is after. And there are different nodes, like node 2, node 17, node 18, node 20, node 25, node 33. So for different nodes, how the frequency voltages are being reduced. This is voltage deviations. So this is before and this is after. Okay, this is before and this is after. So you can see it's crossed the red line. Before it's crossed the red line, here deviations. And in after, it's just below the red line. So you can clearly observe. So voltage deviations before, like before means before the implementation of coordination between wind turbine and battery or between batteries, the voltage deviations were much higher. It's crossing the red color mark. And after I have implemented methods, the voltage deviation is much lesser. Yeah. So this was my research regarding to smart cities. Okay. So if any of the students want any doubt regarding smart city or regarding fog computing, regarding edge computing, and regarding battery energy storage system, so how I have used battery energy storage system to reduce the frequency deviations or to reduce the voltage deviations, you are free to ask me. Is any of them? Is any student who is interested can interact with me. Yes, connect us. Yeah, good morning, sir. Good evening, sir. I'm not able to hear you, sir.
Yes, sir. Yes, sir.
Sir, any of the student is there, you can ask questions. Like in smart cities, the fog and edge computing plays a very important role, and also batteries. I'm audible, right? Mallikarjuna was asking me. Hello, I didn't see my chat. Kanaka, sir.
Yes, sir.
I'm audible only, no?
Yes, sir. Yes, sir.
Okay. Okay, sir. So that's all my presentation. So you can start, sir. Kanaka, sir.
Yes. Yes.
So can I stop sharing?
Yes, sir.
Yeah, thank you.
Thank you, sir.
Yeah.
start?
Yeah, yes, sir.
Admin?
Thank you, Saravanan sir, for sharing your
Yeah.
valuable thoughts on the role of
Thank
this in smart cities and batteries.
Yeah,
I would like to welcome Kanagaraj sir to speak about the topic on peak energy management in modern distribution systems and make our energy high by sharing valuable knowledge with us. Welcome, sir.
Thank you. Share my screen.
Yes, sir. You are visible, sir.
Yes. First of all, I'd like to thank my guide, Dr. L. Ramesh, and Minister of Dr. MGR, to giving this opportunity to share my knowledge to the youngsters. And also, I would like to thank Balamurran sir that's with us today. Thank you, sir. Thank you for giving the opportunity. Yes. So today I'm going to talk about the peak energy management in modern distribution system. So myself, P. Kanaraj, research scholar of Tripoli, Dr. MGR Research Institute. So the main objective of this article is, right, the title is distribution network is normally, right, it is less than 22 kV, either the 22 kV or 11 kV, the nearby substations. So it was dealing with only the underground cables or overhead lines. So and then nowadays the modern distribution grid is employed with the help of the distribution substation, feeders, distribution transformers, then conductors, service mains, so and few of the renewable and energy storage system. So once we are incorporating this renewable and energy storage system, then the corresponding distribution network become a modern distribution system. So the mainly we are plan to do this modern distribution system is, so we are going to implement the optimal number of local distributed energy resources to implement for the peak load management. So the function of peak load management will be explained in the upcoming slides. So and then also we are going to design some intelligent power flow control strategy to control the peak load. So the modern distribution system is mainly, it was challenging to manage the transition and related operations in the market system. So which means that it does not affect the system. We cannot make them as unstable or unmanageable system. So you want to make it a smooth operation, right? That is the meaning of this modern distribution system. So and also we are going to insist to the youngsters that the decision makers, nowadays those who are interested to work in the grid modernization. So these are the few points to be considered. So the mainly we are concentrate on reliability, safety, and then operational efficiency. So we need to get every consumer to get the reliable supply, and then we need to get in safely, and then the efficiency of that operation should be more. And also we have to enable the customer to adopt the DER, so distributed energy resources, for each and every consumer should adopt that DER. So like either maybe a solar and wind. So nowadays mostly the solar is implemented anywhere, so because of the sustainability development goal. So now we are going for the utility of the DER, distributed energy resources. So mainly for utilization of the DER is to reduce the new implementation of your transmission line will be avoided. So if you have a distributed energy resources, so the consumer will take the power from the location itself. But if you are going for the conventional grid, so the power should be taken from the away from the consumers. So we have to travel for the long distance with the help of transmission line. So and then if you have a new people, new kind of consumer are introduced in some rural areas, then we want to implement the few of the transmission network, and we have to waste some of the money for putting the transmission network. So for those places, we have to utilize your distributed energy resources. Then we are bringing to the sustainability here. So we have a certain policies. Certain body will be there. Federal and state and local policy centers are there. So they are mainly concentrating on how the renewable and the efficiency, right? How the renewables and distributed resources will be coming with the proper standards. They are having some standards for implementing those renewables and then good efficiency, right? So and then mainly they are focusing on the CO2 emission. The renewable energy should be they bring out for reducing the carbon dioxide emission first. So mainly the sustainable development goal that the SDG 7 was incorporating these things. So for energy efficiency, so how to maintain the energy efficiency, to implement the renewables, and then reducing the CO2 emission. That is the main aim of the SDG goal 7. So and the reliability and the resilience. So we need to maintain the good reliability of our supply, and then if any unconditional right came, that immediately we bring into the reliable. So that is the resilience. So and some of the integration of distributed energy resources. So the distributed energy resources are solar, wind, and then fuel cell, and many more the batteries, energy storage system, some more. So already the servants are my colleague was discussed about the battery energy storage system in a peak load. We discussed a few things. So again, I'm also going to insist all those things again. So and this federal and state policy center was concentrating on few technologically and few participants. So the technical maybe as a ICT, information control communication technology is there. So NM is ICT. Nowadays all the academic institutes are working on this. So for making the awareness to the people, so they are conducting a few of the new the custom development goals to the consumers and then customers, and then end users like us. So and then some of the electrical vehicles was interpreting it, and solar and wind, some energy storage system. So and so nowadays the building energy management system also coming into the operations. So at present, you know that the BEE was going to introduce the separate exam for a building energy management system also. And then we have microgrids, how the microgrids will be incorporated in this. So and we are concentrating on many of the participants, like some of the normal consumers like end users, and then some people are prosumer. So those people are having a solar, as well as they are consuming it, as well as they are supplying it. So the prosumer may do both operations at a time. So they are going to supply whenever they are having excess of energy by the solar, they are distributing to the grid. So whenever they are required, they are getting from the grid. Okay, the consumers also they are implemented, and then some of the merchants. So nowadays, many people like Tata Power and then Reliance, so they are getting the power and they are generating their own power and they are selling the power to the people. So some merchants are there. So some more will be the technology provider. So like our TNEB people, they are having a certain technology like they are providing the transmission system for doing this all the conversions, right? So and this is the general the layout for energy management system. So we have two controls. One is for monitoring control, another is for power control. So one will be the monitoring of how what are the components was consuming the power. They are getting into the proper single line diagram. So they want to monitor like a SCADA. So nowadays the SCADA will be maintained. So we have operating session and then the video monitoring station. They want to monitor what are the grid is operated, what are the wind turbine is operated, what are the diesel generator is operated, and whatever the batteries are operating now. And then we have to discuss about the solar power, solar panel, and wherever the solar power is implemented. So and then we have to have a different controllers to control that. So for grid and wind turbine diesel generators was controlled by intelligent power distribution cabinet. So this was taken from the grid. So and then few more battery energy storage system. Servants was told that we have a battery energy storage system. So which will be controlled by a power controller. So power converting system. So we have a proper power converter. So like depending on the loads, whether it is a DC load or AC loads. So we can use the proper inverter or chopper. We have to utilize it. So and then we have a solar. The solar we are needing same like a inverter we need a solar inverter. So how the output power from the each controlling unit will be measured with the EMS energy management system. It will be monitored by the proper team. So accordingly, they want to control it, control over there itself. So whenever the peak came, so they have to shift from the general grid and diesel engine to either the battery or some of the solar. So whenever the solar is available, they will inject, and whenever the solar is demand, they will get power from the battery. If the battery also not there, then we can go with that grid. Okay, this is the way they will control. So generally about what is the energy management system, energy demand management, right? So your energy demand management is also known as your DSM, demand side management. So we have to control your demand. So And then another name, it is also called demand side response. So we have to do some modification of the consumer demand. So how the consumers was utilizing it, right? So you want to modify the utilization of the consumer. So mostly nowadays the demand side management is mostly implemented for industries and some of the commercials. So and we are working on it with the residential also. So how the residential also we have to work it out properly. Right? That also we are going to implement. We are giving a certain suggestion for it. So the modification of the consumer demand of the energy through the various methods like financially or certain educational way. We are conducting certain workshop to make the awareness among the consumers. So also the goal of this demand side management is to encourage the consumer. Mainly they want to encourage the consumer to use the less energy during the peak hours. So why? Because already the demand, the peak hours. So if the demand was increased more, so we almost we are balanced with the demand and utility, right? Generation and demand was balanced already. So nowadays the demands are increased more, and the generations are already demand. So nowadays the generations are compensated by renewable energy one. Nowadays they are planning that EB people, right? Electricity board was planning to compensate the demand by mostly in the renewable. So because of transmitting more amount of demand during the peak hours, so we need to add up, right? Extra, we need to invest some investment on transmission network also, because already the existing transmission networks are already full. Okay, so we did a certain survey also with a few of the distribution grid, the distribution transformers. So most of the distribution transformers are already overloaded. So if you want to increase the demand further, so we can go for implementing a new transformer nearby, or we can go with the implementing of new transmission line. So this is the way. So for reducing of cost for those implementation, so we can either reducing the load during the peak hours, or we can utilize the components in the off-peak times. So whenever the load is less, we can compensate on those. Okay. So and then the peak demand management is not necessarily decrease the total energy consumption. So we are not insisting the end consumer do not reduce the energy consumption. So they ask them to change the operating time. They mainly are focusing on it, or ask them to go for certain renewable system for it. Okay, so mainly we are reducing the need for investment in the new networks or power plants to meet those demands. That is the only the thing the peak demand was increased. So and then some examples, right? So we are using some energy storage device. So what is the energy storage unit? So energy storage with the batteries or store the energy during the off-peak hours. So whenever the demands are less, so during those times we are having a battery to store, and then we are going to implement during the peak hours. So this is mainly for avoid the new investment. Okay, so the off-peak hour the battery will be discharged, but this is not a good solution. So we are getting the same power only for during the day. Okay, the per day energy consumption will be same, but the condition is so during the peak time we are reducing it. So due for investment of new networks and power plant. Okay. Yes. So some of the benefits for going for this demand side management. So for going for this demand side management, so if you are reducing the energy during the peak hours, then definitely the reduction in electricity bill. So in our Tamil Nadu, our consumption will be common, but mostly in the north and other countries, they are having a different cost. So during the peak hour, the cost will be more. So why they are increasing the cost during the peak? So making the awareness that end users should reduce the demand during the peak. That is the main. Okay, for those places, the reduction in electricity bills, it will bring the electricity bill reduction. So and then we are using the proper management of ancillary services. So we can incorporate, right, some of the distributed energy resources during the time. Okay, that is the ancillary service is nothing but, so we have a certain reservoir, right, like a battery or certain DGs. We are going to incorporate during the peak hours. Okay, we are going to implement during the time, or we are going to inject during the peak time. Okay, so that will be controlled by this demand side management. And also we can reduce the requirement of adding some new power plants. Okay, so this is already we discussed for upgradation of generation, transmission, distribution services. So that is the main reason for going for this demand side management. So improved integrated resources planning as well as the reduced total energy cost. So we are going for planning some improved integrated resource planning. So some how we are integrating, so we are improved for integrating of all the DERs together, okay, to reduce the cost. So reduce the peak power purchase in the wholesale electricity market. So these are all for other countries. They're having some wholesale electricity market. There is the power provider is there. Some merchant is there. They are getting the power from the power generation. Okay, and then they are selling to the people. Okay, so they are not allowed to give a right for distributing the power during the peak hours. Okay, for wholesale electricity market. They are not able. They are not allowed to purchase more power during the peak hours. So that will be controlled by this management. And then improvement in customer service. So we are giving a good improvement in customer service. So if you have few of them only operating it here, freely we can give the powers to them. And then some improvement in operating efficiency and flexibility. So reduction in pollution and greenhouse gas emissions. So these are all bring into the for peak hours. If you need a more demand, then we need to operate more generation. Okay, if they are generating more, so mostly we are depending on the thermal power station. That is the base. But thermal power station is the base, and then sometimes the hydro also there. But mostly the thermal is more. Okay, so that operates as the base. So if you are increasing the demand, only the thermal generation will cover those powers. Okay, then we have to increase the thermal generation. Then if you are increasing the thermal, then definitely the CO2 emission will be more. Okay, so and that will be reduced while you are using a demand side management. Either we are reducing the power during the peak, or we are operating your equipment during the off. Yes. So and then evaluation of new pro-consumer based model. So we are incorporating the new pro-consumers, having a both nowadays the mini, but TNE people also have they are incorporating to implement the solar for 1 kilowatt hour or 2 kilowatt hour, right, for energy for injecting in the grid. But due to some net metering, they are having a certain net metering. So the net metering will calculate whatever the power they consume, they are separating it to the particular rate. They are doing nowadays that also. They are incorporated to introduce that pro-consumer more. Okay. So increase the energy independence and sustainable dependence on RES. So and also the maintenance of system reliability. We have to maintain. So we have increment in revenue for utilities during the increased rate at peak hours. So definitely we are having increment of revenue for the utilities during the peak hours. In peak hour, the cost will be more, right? So because of getting the compensation of the increasing more power during the peak hours. So and then the conversion of resources. So and the reduction in number of outages and blackouts, the avoidance of the network optimization. So when we are getting the blackout, so mostly right we are having a blackout during the peak hours. So when we are getting a more demand, if the generation is less compared with the more demand, then we have the voltage will come down. Then the properly the relay, right, the under voltage relay will operate properly. Or otherwise, when the demand coming down, then the demand going up, and then generation coming down, the frequency will be accelerate. The frequency also come down. So we need proper under frequency relay also operate properly. If those things was failed, right, then the blackouts will happen. Okay. So on some of the demand response programs are there. So we have mainly two different classifications. So the demand response program may be operated based on the price or based on the incentive. So what is the meaning of the incentive? So what the demand side program will do is the one will be based on the price. So we have a different pricing system. So when there is a off peak, the price may be less. Mid peak, the price may be average. If there is a peak time, the price will be more. Okay. So automatically what happen as a consumer? So we want to operate our equipment like a washing machine or some other equipment, grinder or some more equipment, right? If it is not necessity to operate during the peak hours, so the people may shift over to the off peak hours because of the price. The peak hour, the price may be some 8 rupees. So mid peak may be 6 rupees. The off peak may be 4 rupees, right? So the people will give a priority to operate for those equipment during the 4 rupees time. Okay, 4 rupees time, right? So that is the main aim of price-based demand response, and then the incentive-based. So sometimes what the people will do, if the price is same, for example, in Tamil Nadu system, the price is same, right? So we are incorporating that incentive-based system. So what the incentive-based system is, so we can give a announcement to the consumer, the end users. So if you are reducing the power during the peak hours, so we are giving some 1 or 2 rupees for 1 or 2 rupees for reduction of power. Like that, we are giving some incentive during the peak hour. So already the people will give the load schedule to the corresponding demand response program. The people, those are and the management. Okay. So and then they will request the people, if you are reducing the power during these hours, then we are giving this much amount as an incentive. Then as an end users, what we will do, we are incorporating with that, we have to reduce our power during the time. Okay. So that is mainly focusing on incentive based. So we have different types. So for price based, time of use. So what I told, we have a time. So off peak time one cost, peak time one cost, and then mid peak or average peak, right? So we have one time, one cost. So as well as we have real time pricing. So depending upon the price, so sometimes the generation, sometimes the generation cost may be more during the time, right? So they are fixing the real time pricing. So this is the cost during this generation. They will tell to the merchant. The merchant will fix it the rate. So this is the time. It is the cost. They fix it. So sometimes the critical peak pricing. Sometimes it is a critical peak. So sometimes some social the events are conducted during the time. So immediately the power consumption will be more, right? During the time, so they will fix with the certain rate. The critical peak, suddenly they will put the price will be 10 rupees at this time. They will fix the critical peak pricing also. So sometimes variable peak pricing, so you will vary the peak price also. So extreme day CPP, that critical peak pricing, extreme day pricing, and peak time rebate. So we have some more, right? The cost of the demand will be changed, right, according to the different methods. So some incentive based methods are there. So sometimes we are directly controlling the loads. So sometimes we are interruptible loads we are controlling. So whenever the dynamic loads are coming into the operations, so if you are requesting the consumer, if you are reducing those dynamic loads, then we are giving this much amount of rupees as the incentive. So and then emergency demand response program, sometimes so immediately if we want to control the demand and supply, right? So suddenly we have to reduce some of the loads. Okay, some of the loads, right? Whatever the loads, it is not necessity. We got to reduce it. That is the emergency demand. So if you are controlling that, we are giving some incentive for that. Okay, otherwise the consumer will not accept it for reducing it, right? So we are giving certain incentive for controlling it. Okay, so and then capacity marketing program, and then demand bidding program. So we are having some bidding operations. So we are requesting the utility that if this is the cost, I will reduce my power during the peak times, like that we are bidding it. So and then some ancillary service market program. So depending upon the battery was injected or some renewable, right? Some DG was operated during that time will be, the cost will be different. So then generally the peak load management is ensuring the reliable power at the peak load. Okay, mainly, right? This peak load management is focusing only the power during the peak time. So they want to ensure that either the peak time, right, whether your power is reliable or not. They want to confirm only that. Okay. So and then the growth of peak demand is mainly the power quality and reliability issues. So mainly they want to ensure that power quality is good, or where consumers are getting a reliable power or not, right? If there is any issues, they want to rectify it. And then the need for network upgrades. So they want to concentrate whether it is needed for any network upgrades, or they want to reduce it. They want maintain. Okay. So mainly the peak demand is, so we are adjust, right, with the whatever the existing network is available. We want to accommodate in that. Okay, we are not wanted to incorporate, right, or implement new network upgrades. And then they are concentrating on poor energy efficiency. So and then they go for certain growth. So for distributed energy resources growth. So mainly for to deliver the reliable power and affordable power with the reduced energy state. So for less cost, we are getting it. So and then peak load management is also address the below challenges. So DOs such as the battery energy storage system and electric drives. Electric vehicles will be incorporated in the PLM. So also the PLM was implemented with the help of demand side management only. Okay, so you want to control the demand right during the peak time. That is the peak load management. So conservation in voltage reduction. So how the voltage reduction, right? Normally, if the load is more, the voltage will drop down. Okay, the more load will be putting on, right? So automatically the under voltage will. Okay, we need to concentrate on those things in the peak load management. So it is a part of demand side management, so which is managing the demand at the peak time. That is the main aim of the peak load management. So it also includes that energy conservation, energy efficiency, load curtailment, and fuel substitution. So we are going to implement either the energy conservation is reducing the demand. The energy efficiency is, so we are going to balance it both as a perfectly. That is the efficiency will be good. Then we can go for load curtailment, reducing the load, and then the fuel substitution is, so we are going to implement any distributed energy resources during the peak. Okay, so that is the main thing. The peak load management will control this. So and then some of the thing, right, the review articles. So we done a certain review articles. So based on the techniques and application and ancillary service, the technique. So the techniques we discussed, the demand side management is based on the price based or incentive based. Either the price based or the many type, time of use, and the critical peak pricing is something like. So we did a review on those things as well as the application. Maybe the demand side management is utilized used for industrial or commercial or residential. Okay, so and some of the ancillary services. So what are the ancillary services? Whether they are using a distributed generation DG or solar or wind or energy storage system. So those things based on that they are conducted the different literature review, and few of the literature review I focused here. So these are the same thing. Okay, so in the diagrammatic view, so how the peak demand was, peak energy management was implemented, right? Incorporated, right? This is the peak time, right? This is the peak load. So we want to reduce the peak load to some average. Okay, we are reducing this load this much. So that is called peak saving. That is called peak saving. Peak time we are saving the generation, right? So and then we have one more thing, right? We are this is the amount of required energy. This required energy will be used by a valley filling. Okay, the valley filling is nothing but, so whenever the peak demand is the right, so either we have to shift out to the some other off peak time. This is the off peak time, right? So we are changing this demand in this period. Okay, so we are incorporating in this, right? That is the one way. Then another way we are using some energy distributor, right? Energy storage device. The battery will be incorporated. So these are the peak time. The green is will be the peak time. So those are off peak times. So those off peak time, we are charging our electric vehicle. Sorry, energy storage system. We are charging the energy storage system, and then that will be discharged during the peak time. Okay, so this is the power will be transferred, right? The battery will be charged during the off peak time, and it will be discharged during the peak time. Okay, so this will be just for avoiding the new implementation of your GTD services. Okay, so we did some of the literatures. So and one of the literature is the Hausen, right? He implemented the paper in the title of optical operation of active distribution system based on the microgrid structure. So they are having this one with the microgrid structure. So they are implementing certain PV system and wind turbine, right? Renewable energy sources they are incorporated. So they consider the IEEE 33 bus system. So what they did it in the implemented in two strategies. Okay, for the two strategies to implement this active distribution, make the distribution system as active, right? So the first one, what they did is, so according to the penetration level, like the wind generation, how will be the wind depending upon the time period, and what about the solar irradiation during the time. So they are calculated those things. So based on that, right? So they are generating those things and they will store it in the energy storage devices. Okay, like battery, and then they are incorporating in the particular place. So wherever we need, right? Which course we need a wind turbine, which course we need a PV, what is the size it is required. So those things will be incorporated based on the algorithm, right? So they implemented the Monte Carlo simulation algorithm. So based on the algorithm, they find out so what is the optimal size and where it is suited. Okay, so that will be calculated the first stage, And then the second stage, the operation of quality was evaluated. So they want to evaluate those things by non-dominated genetic algorithm too. They are implementing the multi-objective optimization. So they are concentrating on so how the PV and wind turbines are shifted in the particular burst, as well as and how the energy will be reduced, or how the energy bill will be reduced. Those things will be incorporated in this curve. And this is the algorithm they implemented. Okay, the Monte Carlo simulation algorithm was implemented. So this is the diagram. Okay, so for time constraint, just I will explain you what are the things is did in the paper. So I am not interested to explain that entire algorithms and all. Okay, so due to the time. So and these are the two things. One is the before addition of ESD, energy storage devices. Okay, so before is the dotted line. So before energy storage device incorporated, the power is more. So it's a kilowatt, right? Almost it was consuming. It is maybe the peak, right? During the peak, almost it is consumed 43 kilowatt power. So after we are implementing the ESD, it was reduced to some 1 or 2 kilowatts was reduced. Okay, so that power will be compensated by your PV and wind generations. Okay, so and this is for the power losses. The losses will be reduced. Okay, almost 2 kilowatt will be reduced. You know that the 2 kilowatts it is for 1 hour, right? It is usually for many more hours, right? Almost they are reducing much amount of demand will be reduced. And this is for the voltage, based on the voltage. So if there is a more load, the voltage will be less, right? So before adding the DSD, without installing that energy storage device, your voltage profiles are very less. Voltage profiles are very less. So after implement the ESD, your voltage profiles are improved. Okay. So here it is having a larger network. That's why the improvement is very less. You don't think that the voltage improvement will be just 0.05, right? It's not like that. So it is implemented in kilowatt, right? That's a megawatt, right? Because the losses itself, it is almost 2 to 3 kilowatt, right? Think of it. So based on the proposed system, we are implemented in 3 scenarios. So we are operating with the single objective and multi-objective. So the single objective is mainly focused on without right implementing the energy storage devices. Okay, so without the construction of microgrids, and then second stage will be a with construction of microgrid. Okay, so and also with your ESD, without ESD, they are having a different category. Okay, so like they are implemented for 3 scenarios. So and these are the outputs for based on the 2 stages, without construction and with construction. So we are getting these are the errors, the index errors will be getting it. So when you are having the error will be very less during the multi-objective. You can see this is the single objective, right? And then you're going for the multi-objective. When you're going for the multi-objective, they're getting a less voltage, right? The error will be very less. Okay. So and then the another author Muhammad will be implemented the optimizing energy management and control of distributed energy resources in islander microgrids. So this is for islander microgrids. So this islander microgrids also they are considering the 33 ITP 33 bus system. So here they are implemented in fuzzy logic, and then they are implementing one more algorithm like harmony algorithm and genetic algorithm. Both combinedly it was implemented. Okay, the hybrid system was implemented here. So this is a general algorithm, based of algorithm, and the result was discussed, right? So based on the both combination of your harmonic search algorithm and GA combined and then separately. So when you are combined, right, your voltage was boosted or improved. Your voltage was improved. Okay. So here also they are giving for stability index. Okay, that is also for good for the minimum time good for harmonic search and genetic algorithm together. Okay, the PD is the problem. So the optimization problem was formulated in terms of multi-objective problem to minimize the fuel consumption of DG. Mainly, it is implemented for minimizing the fuel consumption. They are having a DGs and separate DGs are implemented. So they are reducing the fuel consumption for that, and also they are implementing voltage profile is more, and then stability of voltage profile is based on the security constraints. So in this approach is implement the constraint of optimal generation of DGs, autonomous microgrid by increasing the divergence speed for solving the this optimal solution. So we are implementing this with different automatic, right? Automatic system also, autonomous microgrid. So whenever the microgrid is separately there, so this DG alone, they are only if you are going for autonomous, you can go only by DGs, distributed energy resources. Either we can use the solar, wind, or DGs alone. So in this paper, they are interpreting only DGs. So and Sanchi, so he is concentrated on power management, peak energy management using the renewable for DC microgrid. So he is also considered for DC microgrid. So this DC microgrid is mainly focused for avoiding the grid failure or blackouts. Okay, they want only the powers in the DC. Okay, we are having a loads also in the DC, right? So all the loads they are having only in the DC. Okay, so these are the loads. The loads are operated in DC supply. Okay, so we are having a PV, battery, ultra capacitor. So these are the energy storage devices. They are utilizing it, okay, for renewable resources. So they are using a proper converters, right? Because our loads are DC. Okay, so we are converting this into this. So this may be avoid your grid failure and blackouts. Okay, so we are having a proper relay. Relay may be mostly incorporated in DC supply, operating good in DC supply. So to design a comprehensive power flow control strategy and explore for the different practical scenarios. So for this control strategy was implemented with the help of the real-time distribution system. We have a separate real-time distributed simulation is there. We are incorporating the control strategy used on that real-time simulation platform we are performing. So mostly this will be incorporated for a small scale integrated, and only for small scale they are implementing. So they are using only for certain residential or some commercial purpose, not for the industry, right? And these are the algorithm they implemented. So they are going to implement the algorithm is based on the battery, PV, and then the loads. So they are checking the load demand with the battery SOC. If the battery SOC is good, battery will supply. So if the PV is present, first giving the period for the PV. If the PV is not present, then it will give to the where a battery SOC will check. If the SOC also not good, right? Then they go for the okay. So this is the way they are interpreted this one. So these are the strategy of control strategy. They are doing it in that way. The one is for outer control. The outer control they are using current control. So another one is using the inner loop control is used for low pass filter. The outer will be the high pass filter. They are using this filtering out, right? So they are having a solar. Solar will be implemented with the MPPT algorithm. So the MPPT, the maximum power point tracking. So it will always concentrate the irradiation of the solar. So it will tilt your solar panel according to the where the solar radiation is. Okay. So and also we are giving the grid voltage. Also we are giving it here. They want to compare it both. Accordingly, the power strategy control will operate and it will give a supply to the converters. The converters will generate the power and it will supply. And this is the simulation parameter they consider. So they simulated in real-time RTDS platform. They are having taken the parameter this one. Okay. These are the output they got it for real-time outputs. So, and then the one more author is Lokesh Gupta. Is implemented in the multi-objective home energy management with the battery energy storage system. So they are finally coming to the implementation for residential. Okay, so till now it is implementation for general. Okay, for any commercial or distribution. Mostly it is for distribution. Now these are now the upcoming papers are mainly focusing on the residential energy. So Lokesh Gupta was implemented the intelligent multi-objective household demand side management with the battery energy storage system. It is mainly implemented for minimizing the energy as well as reducing the peak load demand. So we are finally coming to the conclusion that we focusing on minimizing the electricity bill or energy consumption, and also we are concentrating for the peak demand. At the peak time, we are reducing the energy consumption. Okay. So and this author was implemented is the multi-objective mixed integer linear programming technique. So to solve the residential demand side problem. So he take 4 residential consumers. He taken for the 4 houses. For those 4 houses, they are segregating the loads into non-suitable appliance, time suitable appliance, power suitable appliance. They are divided into 3. So what is non-suitable and what is time suitable and what is power suitable? non-suitable appliances are, so we are not able to shift it. So for example, if you require the light during the evening, right? So we need that light energy. Okay, so we don't switch off that light, okay, because of reducing the peak, right? And then the refrigerator is continuously running 24 hours, right? We are not able to control that, right? So and then we need a TV, right? For entertainment, we are doing in the evening time. We are doing some entertainment, right? So many people they are insisted that TV must need, right? So depending upon the consumer preference, okay. So what about the loads they are needed during the peak time also? Those loads are called non-shiftable appliances. And then we are classifying into the shiftable appliances. So the shiftable appliances are we are having the washing machine, wet grinder, right? So and sometimes they are using AC also. Sometimes the people have a time shiftable and the heaters. Okay, so these are all we can bring into the shiftable. If it is it is also based on the consumer preference. Okay, so I am giving some examples. So and then power shiftable appliances. The power shiftable appliances are so the charging devices like you are having a solar, right? In our house we are having a UPS, right? The battery is needed to charge. Okay, and then some of the latest pro consumer they're having the electric vehicle. They want to charge your electrical vehicle, and then we need to charge our like motor also we can use it as a power shiftable. Like we are having a house with having a single phase index motor to pull the water to the tank, right? They are having a motors. So those motors also we can come into the classification under power shiftable. So whatever the loads having a more power, they are shifting it. So what we do in the night time, we want to store the water full time. We want to store during the night time. That is our main aim, right? The morning we are utilizing the water. The night time we are going to, right? So fill the water tank. Okay. So for that one, we need to run the motor for half an hour or 20 minutes, but we don't have any constraint. We need to switch it on during the 6 o'clock or 8 o'clock. There is no constraint. You can able to switch on after 11 or 12 also. Okay, so or early in the morning also 4 or 5, right? So those things we can shift our own decision, right? So mainly the author focusing on this time shiftable and power shiftable appliances during the peak. Okay, so this non-shiftable they want to achieve, right? So and they are classified into 6 different scenarios. So with the 2 different cases. So the 2 cases will be so the single houses they are considering for 4 houses, right? In this paper. So they are implementing this algorithm for single house at a time, and then all the 4 houses together they implement. Okay. So and also they implement these are the constraints they consider. So based on the constraint, we can see the red lines will be the scenario 6. The scenario 6 will be based on you can see that right, the scenarios are having a different. The scenario 1 and 2, right? So which is based on a cost. Scenario 3 and 4, it is sorry, scenario 1 and 2 will be 1 is for cost, 4 is also cost. The 1 is for single house, the 4 is for multi house. So your S2 is for minimizing only peak load, and S2 and S5 is for peak load, S2 for single house, S5 for multi house. Similarly, S3 and S6, right? So which is implemented for both energy cost as well as peak load both at a time. Single house, S6 for multi house. Okay, these are the things they did. So they reduced further also. You can see the last one, scenario 6, which is multi house, and then with the implementation of that battery, all those things also. Okay, battery energy storage device also together, right? They are getting a good. So the same author again they implemented another one with the renewable energy integration. Earlier they chosen only for battery. The battery is charged during the off peak and they are implemented during the peak. Okay, they did only that, right? Then again they come into this cooperative game theory approach for multi-objective home energy management with renewable integration. They consider now wind and solar also. Okay, the same circle. So only the difference is they are considering wind and solar. Now they are considering wind and solar. So they are having a same 6 scenarios. So the 1 and 4 for cost management. The 1 is for single house, 4 is for multi house. Similarly for 2 and 5, right? So 2 for single house, 5 for multi house, peak load, and then both multi-objective cost as well as the peak. Okay, so they did it on 3 cases, 6 scenarios with 3 cases. So what are the 3 cases? So now they are having a renewable energy, right? So without renewable energy, what happened? All the 6 scenarios they are checking, and then with renewable energy without battery. Okay, but with renewable energy, it is a more complicated one because renewable energy sources are intermittent in nature, right? We don't know when you are getting a more powers, right? It is always intermittent in nature. Okay, they are checking in that case also. So and then home energy management with renewable energy sources with battery. So we are having a battery also. So why we need a battery? So whenever your demand is more, we have to store it. Okay, and then we have to pause, right? So that is the way. Okay. So these are the same constraints they consider. So additionally, they are considering about the PV, right? The PV and wind generation limit, okay, minimum maximum limit they are considering. And also the power balance equation, they are adding with the PV and wind together. Okay. And these are the appliances, right? We are having a 5 consumer. Here they consider the 5 consumer. The earlier problem they consider 4 consumer. Here they consider for the 5 consumer. So these are the consumer time preference they collected the time preference. So the consumer will decide what are the equipment they can have for time suitable and what are the appliances for power suitable, what are the appliances for non-suitable they consider. So here they are listed out only for the time suitable and power suitable because those two equipment only they are going to cut. Okay. And these are the monthly bill consumption. Okay. Peak hour, these are the costs. So we are having a different consumption, right? In our Tamil Nadu electricity board, they are increased the rate nowadays, right? So which is having a difference. Slab rate was changed, right? So similarly, the author also consider like a slab rate, but the slab rate is considered for 3 different peak hours. Okay, so peak hours, mid peak hours, half peak hours. But in Tamil Nadu government, they are having only the common cost for different slab rate, right? And this is the storage, battery storage capacity they consider. And these are the results they are getting it. Okay. So and then the one more author, Joe, right, is a distributed optimization framework for energy management of multi-smart with the distributed energy resources. So they are considering same for the residential consumer, but they are having a 2 different control strategy, right? Energy management system. So they have a central control management, central home energy management, but here they are using a decentralized home energy management. Okay, they want to compare the result with the decentralized energy management with the control management. What is the difference between centralized and decentralized? The centralized means the only one people they control everything. The decentralized means so whenever we repair or something, whenever there is a sudden abnormal conditions for exist, they immediately we want to operate. Okay, so that is the one. So they are divided into 2 levels. The one is for local home energy management. So the local home energy management for each and every consumers they are having the control, and then the global home energy management. So this is the one they are controlling the houses. Almost how many houses they are controlling for 4 houses or 5 houses. They are having one control system. Okay. So what they will do actually? So this local home energy management system was controlling only the load appliances, whatever the appliances they are having, whatever the if there is a pro consumer. So whenever they want to inject the PV, whenever they want to replace the grid, right? Those things they have to plan. Okay, they will plan in their house appliance alone. Okay, so whatever the smart appliances they are having, only they want to control those things. Okay, this is for local, right? And one is for global. But global, what they will do is, so they will interact with these house people and utility together, and they want to control it both. Okay, so what is the energy at present they require, and they will interact with the utility, and according to the utility, whether they are going to increase the generation or they want to implement a new PV or some distributed energy resources. They want to control the demand and the generation in the common. Okay, from the utility and the consumer, they are controlling together. Okay, so energy scheduling will be happening, right? The energy scheduling will be happening. Yes. So, and these are the things. The global home energy management system was it's operating only the ESS. Whenever the energy storage device system was operate, they want to put a schedule for it. Okay, so based on your tariff and then demand response event, according to the voltage level, they deciding. Okay, suddenly they will decide, right? So similarly for the local home energy management, also same. It is depending on the cost. Whenever the cost is more in the utility, they will reduce it. As well as the consumer comfort, even though if the cost is more, right, the consumer maybe needed it, right? they can request it, and then based on the weather conditions. There is the weather was less. Like sometimes we are running the summertime, we are running the AC. The winter time we are not running on the AC, right? Likewise. Okay. So those control will be done it by the local. So this is the algorithm they use for it, and they are getting the appropriate results. Okay. So they compare the result with centralized and decentralized. Okay. So when you are using a decentralized, the cost will be less. Okay. When you are using the decentralized, the cost will be less. We are having the different case studies also. So depending upon the appliance load shifting, and then incorporating the load profile or ESS like that. Okay, having a different constraints. So and then the last that author was Digi was using that Pareto evaluation with equilibrium based decision. So they are using for multi-objective optimization for multi-houses. They're having a many houses. The houses are classified into three categories: type 1, type 2, type 3. The type 1 consumers are having a pro-consumer, prosumer, right? They're having a both PV, EV, and then some other smart appliances. They are having it. Okay, so they will inject also anytime when they have more energy. They will inject, and then the another structure will be only having a EV and then normal smart appliances, and then the third type will be the general consumers. They are not having a electric vehicle or PVs, right? They're having only that appliances alone they are using. Okay, with those. Okay, so they are going to control these all the three, right? So with the energy management system, with the ADN, active distribution network, they are using some active distribution network. Okay, so multi-house. So the objective of this one is the maximization of consumer satisfaction. Mainly, the author will focus on consumer satisfaction, because the end users should not be right, so affected, right? So the end consumer should be satisfied at any time. And then the minimization of energy cost, we have to reduce the cost as minimum as possible. Okay, so and also we have to use the peak to average ratio. What is the peak to average? So already we discussed the earlier peak saving, right? We are reducing the peak over to the average, right? So we want to find that peak to average, what is the value we want to maintain. We have to ask minimum as we have to maintain. Okay, as minimum we have to maintain from peak to that average point. Okay, that is the peak to average ratio should be maintained. Okay, so almost they are evaluating for 100 houses at a time. You can do with the simulation, and these are the system they consider. Okay, the parameter for Pareto, right? Tribute evaluation. They are taking these parameters, and then this is the system they are considering for simulation, and this is the algorithm they implemented it. And finally, they are getting a good solution. Pareto, right? Tribute evaluation, they are getting a good result. Okay, so the results are presented here. So here both utility company as well as the consumer end users, right? Both will be satisfied. Okay, consumers and utility company will be best, getting a best. Okay, satisfied. So based on this literature review, we identified some of the inferences. Okay, so and some of the inferences they want to discuss it here. So the mainly, right, we need to create the awareness among the people that what is the peak hours and what is the off peak hours and what is the mid peak hours. So what happened during the peak hours and what are the things happen for the off peak. Okay, so you want to create the awareness. So these creating the awarenesses are mainly made by a workshop, or so like we are doing now, like a workshop, right? They are giving some guest lecture, right? So these are the things will make to the people. Okay, so general audience we want to cover it first. Okay, so without knowing the concept, right, everybody should not reduce their loads. Okay, so make the social awareness between the consumer. That is the main aim in this one. So nowadays the SDG goal was implementing everywhere. Okay, they are creating more, right, awareness among the people now. So I think you people are known, right? Our IGN will be doing a good in creating the awareness among the people. So that the 999 challenge, and then the 999 project, they have a certain project, 999 project, something we have. We are getting some award also. The Solid also getting some awards based on it, right? For creating the awareness among the people. This is the main aim of the thing, right? That is the main aim. So and then we have the required amount of tools, customized tools we want, like demand side management and some more control we need among the residential, because 40% of loads will be replaced by the residential generally, right? 40% of consumers are residential. So mainly if you are focusing on the residential, right, that 1 day, 1 unit consumption was already the Ramesh was making the awareness among the many people. So they are also satisfied. Okay. Similarly, we also work it out more, right? We need to propose some certain tools among the residential, right? Like a controller we need for controlling the equipment for a smart way. So and also we proposed some thermal energy storage. TS is thermal energy, combined TS and solar PV. So this is mainly required for the dairy factories. What is the dairy factories? They need to maintain the particular product in the particular level of temperature. Okay, we need to maintain, right? For those industries, the TS based things are very important. Okay, so we need a proper significant cooling methods. Okay, we can use the thermal energy storage devices must for those places. Then they are not required to take the power from the grid if you are using a proper thermal energy storage system. Okay, so the off-peak period, the thing will be stored, the cooling energy will be stored, and that will be utilized during the peak hours. Okay, that is the concept mainly the TES. So and then we are using the renewable generation uncertainty modeling. So we need a proper modeling for renewable energy because the renewables are indeterminate in nature. So we need a proper modeling is required for it. Okay, so like we have to identify the information gap theory and then some optimization technique to implement all those things. So finally, we are home energy management system is required for individual residential house. We need to concentrate on individual houses. Okay, we need to concentrate on individual houses. So how the with the help of energy storage devices, some of the distributed energy systems, we need to implement for individual houses also, if possible. Okay. So at least we can go for multi houses. We haven't for 4 or 5 houses together. We need a certain energy storage devices to incorporate it. And then we have to go for the development of solar PV storage technique, and it will be made by a higher efficiency and a lower investment cost. Okay. So and then we have go for the larger peak saving and value filling is must. So we have to use for reducing the large power, or that will be compensated by value filling. So wherever that is already I told, the peak hour load will be shifted to the off peak hours. Okay, that is the one. So and then some real problems in industrial and healthcare should be addressed, and then we need a proper simulation optimal techniques for that industrial and healthcare, because the healthcare and all we need to concentrate much, right? Because whenever we need to operate that equipment, the power must be needed. Okay, so the emergency condition and all we can use that healthcare equipment only. So we need a proper power management there. Okay, it should not be affected, right? So and then DC microgrid will be implemented only wherever the conversion grid does not exist. Same, the DC microgrid is mainly implemented in the rural areas. So wherever the power network is, right, the transmission network is not implemented much. Okay, and then in the view of the data centers and telecommunications, so these people and all they're concentrating on separate microgrids. Right? Okay, so and then the latest optimal techniques was extended in industries and some of the controllable load. They want to implement the controllable loads, right? So whatever the controllable load, what is the controllable? The industries they're having a different loads. The few loads will be continuous, right? We have to run it continuously, and few operations may be done it later also. Okay, so for those loads will be requested to operate during the off-peak hours. It is better to implement that the peak demand, the peak energy management better. Okay, they have to reschedule their process, the processing of that controllable loads, right? Not the uncontrollable loads, right? So and then with the help of Ramesh sir, we conducted some of the survey. So among the residential consumers, okay, so around 2,000 people we conducted the survey. So based on the survey, right, the main aim of the survey is, so what happens when the summertime, mostly the summertime the demand is more. Okay, mostly the power cut will be happen during the summertime. Okay, and then a lot of disturbance will be happen for the residential consumers, right? So we did a survey with the residential consumers. So and then we started to collect the form, the home energy summer peak survey toward the United Nations Sustainable Energy Goal, Sustainable Development Goal 7. So we did this survey for this SDG, okay, mainly for SDG 7 we implemented this, okay, among the residential consumers. So this survey will be help to identify the solution on the summertime, mainly what to do for summertime for the residential consumers. Okay, what way we can able to reduce the demand during the peak time for the residential consumer we implement, right? So these are the survey questions. The mainly the first, which month did you pay the highest bill, right? The many of the people, right, when they did a survey with this, right? So among the consumers, so which month the people are paying the totally 6 months. Mostly the billing will be the bi-monthly, right? 2 months once. Okay. So based on that, we discussed with the consumers. We collected the survey. So they paid more amount during the April, May. Because that is the summer season, right? April itself, the summer will be started. April, May, June, July, right? Almost these are the peak time summer season. So for those will be occupied almost 58% of people will be giving April, May, and then the 21% of people may paid June, July also. Okay, so they are paying more electricity bill during the summer time. Okay, so and then we asked about the equipments, right? So choose the topmost reason for paying the electricity bill. So we conducted the survey among the people that which equipment you feel the cost will be more for you, right? So many of them they told AC. Okay, so most of the people they told with the air conditioning, but the few they told heater also, but the heater will be mostly implemented during the winter season only, right? The majorly the people was using the AC during the summer time. Okay, so almost 70% of people was giving the thing during the due to maybe AC. Okay, so and then we asked the people also that how many ACs you are having in your home. Almost 38% of people are having a single AC. Almost single, two and three ACs having more. So almost 10, 30, 28 and almost 76% of people are having a AC. Okay, simply we can count. So almost 76% of people are having a AC. Then definitely they have to run during the summer season. So definitely they are having a electricity bill is okay. So and then and also for general way we are having a energy storage device in your house, right? Like UPS you are having, right? So we make some general question like whether the people are having an inverter in their house. So if they're having an inverter, sometimes they can able to run the battery supply during the peak time. Maybe the light loads or something we can control it, right? So we did that also. Most of the 60% of people are having an inverter in their house. So mostly that the UPS will be available in every house because of the power demand happened in the during the last 6 years before, right? So the summer continuous power cut totally 4 hours and 5 hours power cut may happen, right? So that time everybody get a knowledge about the inverter and UPS, right? They purchase everything. Okay. So and then we ask the people how to rate based on the summer. Okay. How do you feel the electricity during the summer time? Okay, whether they may be comfort or discomfort. Discomfort is 1, the comfort will be 5. So according to this, right? So almost 24% and 31, almost 50% of people was giving, right? Discomfort. Okay. So I think green will be a 5, right? And then blue will be a 4. Okay. So there some they will be discomfort mostly. And then how rate the interruption which will disturb your sleep during the peak time. So that means that the one is less, and then the 5 will be more. Okay, the discomfort. The one is the less discomfort. The 5 will be a more discomfort. Okay, so actually this is not like this. So the 1 will be a less discomfort. The 5 and 4 will be a more discomfort according to the rate. Okay, so most of the people they are discomfort. Okay, so similarly for interruption of sleep, right? Many people during the night in the power cut, then they are not able to sleep properly, right? During the AC will off, right? So and that also, right? Most of the 50%, more than 50% of people was telling. So it was disturbed, right? Lot of disturbance during the night. Okay, it is also same. So a lot of the disturbance based on the rating. The 1 is a lot of the distance, 5 will be the more disturbance. Okay, it is based on not more disturbance, right? It is based on the disturbance one. Okay, how will be the disturbance? Whether it is 1% or something by 5. Okay. So and we did some of the work, okay, based on this survey. Okay, so before the survey we did some more thing. So we start collecting with the residential. We have an apartment like 64 house apartment. We conducted energy audit. We conducted the pre-audit, and then we went for the conclusion that many of the houses, right, they are consuming more during the summer, paid during the summer. And we conducted the survey also for those houses. Also we conducted the survey. So we taken that the system of 64 houses, with the 47 inverters having the 47 houses having the inverters. Okay, So and what it is, we did the simulation with the excellent. So first we take the measurement among the total supply. So we have considered the fluke meter. We've taken the fluke power energy meter. Okay, we taken the 3-phase power energy meter. The fluke we taken about 38 series. We consider. We taken for the apartment. We measured the total power consumption among the 64 houses. Okay, so and then we calculated the measured the power among the single houses also. Okay, so I did my houses also. Okay, I was living in the one of the house I was living there. I conducted energy consumption of my house. So I want to record the energy of my house. And then we have two different houses. So 3 BHK and 2 BHK. So we did a power analysis. We connected the power analysis, measured the power in the 2 BHK and 3 BHK. So according with the 2 BHK and 3 BHK, so we did a load flow study. 64 houses, right? But we have 4 floors. Each floor we are having a 16 houses. The one will be the right side, another will be the left side. The power will be flowing in that way. Okay, the power is coming from the transformer to filler box. The filler box will be divided by 2. The one is for right side and then left side. Okay, the right side 32 houses are having with one filler box. It is connected in a radial system. Similarly, the left side also the power is taken by the another filler box. They are taking another 62 houses. Okay, each floor 32. Okay, the first floor will be connected directly, and then the second floor will be looped from the first floor. Okay, it's a radial system. Okay, so then voltage at the first floor may be good. The voltage at the fourth floor may be less, because so when you're coming for the fourth floor, the more amount of loads should be added before it. Okay, so this is the thing you must understand is how the load profile is, how the voltage profile is, right? You must understand. Okay, so we did the normal Dixieland load flow. We did it. So we did a quasi dynamic load flow, because the time to time the power will be differ, right? The residential consumer, the time to time power will be differ. So we taken the few single house reading we consider, and we taken the rough estimation of how the power was changing it, right? We made the rough load flow study. Okay, so according to the load flow study, we implement the loads for the other houses also. Okay, we taken which house is consumed more power, right? So for those houses, we conducted the energy audit. We measured the data. Accordingly, we divide the other houses. Okay, so and these are the load flow we did it. Okay, so the normal load flow we did with the two things. One is for existing power, another one is for load flow. Okay, so second power. Okay, one is for the grid power, another one is for the utilized power by the loads. Okay, and then other will be the loss, right? So we did a time variant, that is the quasi dynamic load flow is available to a Dixieland. So that is time to time we can change the load later. Okay, so and then we incorporated one PV. Okay, so the 30% of load will be compensated. We consider that among the total power, right? As per the peak power, we consider the peak power here. According with the peak power, so what we did, so we consider the highest value, and then we are going to compensate 30% of the highest value will be compensated by battery energy storage system. Okay, so we implemented the PV. So PV was implemented to charge the 30% of the load will be supplied during the peak time, and then the battery also designed based on the 30% of the peak load. Okay, so the daytime the PV will be so battery start, the power will be stored in the battery, and then during the peak time this battery power will be discharged to the all the loads. So I consider the loads, those are the houses are having an inverter. Okay, so I utilize that battery, right? I'll consider all the batteries, and I taken to the separately one battery room. Okay, all will be connected together, and I was considering it. Okay, for avoiding the investment cost, right? So those 47 houses we consider, and then few of the battery, if it is required for 30% for compensation, right? So we purchase it for the battery. Okay, so for simulation purpose we consider that. Okay, real time we are being able to implement it, because the end users they are not accepting it. So we are going for the 10% load reduction, 20% load reduction, 30% load reduction, 40% load reduction, sudden load increment, whatever. Okay, so this is for the normal, and this is for the sudden increment of 40% load. Okay, we consider the two cases. Okay, so the normal load flow we consider the two cases. One is for normal operation. This is for the normal. So if suddenly the load was increased, because the residential loads we cannot determine it, right? When it will be the values will not be determined. Okay, so it is always interpreted only the same like renewable. Okay, so we approximately assume that if suddenly 40% of peak load was raised, what happened? So suddenly the peak load was raised suddenly. So suddenly the losses will be getting more. Okay, so that we do it with the PV also, and then battery also with the PV battery based system. Solar powered battery bank, right? We put the name as solar powered battery bank. So this solar powered battery bank will be, the sizing will be designed based on the PSO algorithm. Okay, the modified PSO algorithm. So accordingly, we did this thing. We reduce the voltage. Okay, so these are the voltage profile, right? So for the different cases, so we have a different floors, right? Floor wise, we take under consideration, right? We take the first floor, left and right, second floor, left and right, third floor, left and right, fourth floor, left and right. So how will be the voltage profile? Okay. So with the base case, okay, as well as the 10% load increment, 20%, 30%, 40%, whatever. This is for the normal, and this is for the implementation of PV. Okay, almost it is maintained constant. Okay, here we can see the bus to bus, the thing was happened here, right? But what we did is, so we are shared the energy storage, right? The power battery energy storage power will be for each floor we share it, because each floor the battery is having now. So every people are having a inverter connection, right? Only for those people loads only we are controlling. Okay, because we taken those people batteries, right, as a cumulative battery, right? So we are giving power to those people, and this is the profile we find out. Okay, this is for voltage profile maintain, and this is for the cost, how much energy saving will be happen. Okay, so how much, this is for the existing case, and this is for the proposed case. So the consumption will be reduced much. Okay, so as well as this is for the saving of cost. Okay, this is for cost saving, so we can save much more cost in implementing the battery. Okay, so and then we also did with the another work. So like during the literature review, we discussed about the house, right? The load shifting algorithm, right? We controlling the loads of the individual houses, right? So we did that also the second work, to minimize the electricity consumption cost and peak load among the residential houses. So we consider the 4 or 5 houses, right? And we collected the load pattern of those houses. So I did it real time. Okay, how will be the load the people are switching on, right? I consider the nearby house people, right? Nearby consumers, right? I went to discuss with those people, and so whenever we are switching on the lights, whenever we are switching on the AC, whenever we are switching on the heater, and then mixer grinder, right? The refrigerator, right? Fan, TV, all those things I consider it. So accordingly, I consider my own load pattern. Okay, so I was taken my own load pattern. I am going to implement with different algorithms. So MPO, Monarch butterfly optimization, and then CSO, cross search optimization, artificial fish farm optimization, and then the one more EMPO was we implemented that one. We have a combination of this MPO and CSO, because the MPO and CSO was good during the analyze. Okay, so we taken the both together, and we made a hybrid algorithm, that is evolutionary Monarch butterfly optimization, because the Monarch is the main, and then we are incorporating the cross search, the migration operator with that. Okay, so we implemented the new one. Okay, so based on this, we have different cases also we consider. So first we consider only cost, minimization of cost. Similarly, the author Logesh Gupta was read, right? So he considers the 3 cases. Now, one is for minimization of cost, minimization of load, and then minimization of both. Okay, so we consider that paper of the base paper, and we did in that way. Okay, so we was consider the cost alone, and then the peak alone, and then both cost and peak. Okay, we consider for all the 4 algorithms. So according to the 4 algorithm, first objective is for minimization of cost. So when you are minimizing the cost, right, our hybrid algorithm, right, will be a less cost during the time. Okay, only consider the cost. Similarly, going for the peak load, right? So here also we have best getting in the EMPO, evolutionary Monarch butterfly algorithm. So others are getting more, and then finally we are coming into the combination of both hybrid, right? So we are having a both cost as well as the peak. So in that one, we are getting almost we are getting our evolutionary Monarch butterfly optimization was getting good research. Okay, are getting almost nearer. The AFS solver was good. Okay. So, and then according to the fitness value, right? According to the peak value, it was good. So this is regarding the peak load, and according to the fitness value, right? We are having a certain fitness because we are considering both cost as well as the peak. We are having a multi-objective optimization, right? We have multi-objective function. So then that multi-objective function, the fitness will be considered as so squared, weighted square method. So we have considered the cost as well as the load, okay, peak load, right? When you are considering the fitness value, so our evolutionary monarch butterfly optimization are getting the best. Okay, they're getting the best load. Okay, so these are the things we did. And then the upcoming we are did this one is for single house, but also we are going to do the same operation for multi house. We are going to implement it. So these are the research we find out. And then the upcoming we are going to control the end user loads also. But as per the TNEB norms, that distributor loads is not able to control. But even though we are getting a survey with consumers, those who are willing to control, they are getting the, and we are going to control the loads inside the house also. We are going to do in the real time. Okay, that is also our other work we are going to do. Yes, these are the work done in the peak load. So these are the main importance I want to convey to you people regarding the peak load management. Okay, the peak load management is the main tool to implement the SDGs 7 goal 7. Okay, so we have to reduce the generation, right? We have to implement the renewable. Okay, this is the main aim of your peak load management. Yes. Any queries you can ask. Ready to answer. Yes, audience, do you have any queries? Yes, any doubts? Yes, any of you having doubts you can ask for. These are the research till now I did it in the peak load management, and a few more we have to do. Yes, any queries?
No queries, sir.
Thank you. Thank you for all giving this great opportunity to give a importance of peak load management to maintain the sustainability, the green. They are going into the green, right? Thank you. Thank you.
Thank you, Peak Energy, sir, for sharing your valuable knowledge in peak energy management in modern distribution system. Next, I will call P. Elilaracy ma'am to speak about the topic on smart meter benefits in sustainable smart cities to share her valuable knowledge with us.
Good evening. Can you hear me?
Yeah, ma'am, you are audible.
Yeah, sure.
Yes, ma'am.
Hold on, I will share my screen. Are you able to see my screen?
Yes, ma'am, we can.
Yeah. evening to everyone. First of all, I'm expressing my heartfelt thanks to Ramesh sir, Balamurugan sir for giving me the wonderful opportunity to explain my experience regarding the research which I involved towards the sustainable environment. So the today topic I'm going to present is smart meter benefits in sustainable smart cities. So start with the presentation. Okay, I hope the screen is visible to you. Am I right? My screen is visible, right?
Yes.
Yeah. So myself, P.L. Ilarasi, I'm doing my research in Dr. MGR Educational Research Institute. So regarding smart city, everyone nowadays, everyone talking about smart city, smart city, smart city. What is the actual meaning of smart city? Anyone from this audience, right? Can I get the answer? What is the exact meaning of smart cities or rough outline of smart cities? Anyone? Actually, we are in the process of approaching the smart city, right? Nowadays, we are in the process of approaching our living style towards the smart cities. Can anyone tell actually how exactly smart city looks like? Anyone from audience? Any answer?
Everything is available for everyone.
Okay, everything is available for everyone. Okay. So, any other answer? Okay.
Yeah,
Then-
madam. All
Yeah.
sensors are interconnected.
Sorry, sir.
Sensors are interconnected.
Okay, sensors are interconnected. Okay. Anything else? Any answers? Okay. Smart city. Smart city is nothing but we are going to mimic our phone. We already use our phone, right? Smartphone. The exact characteristic will be if you consider the conventional old mobile phone, we can talk to another person, we can message to another person. So the functionality is very limited, right? When you take the traditional mobile phone. But when you come for smartphone, the functionality and features are abundance. So we can do anything from anywhere, and we can monitor anything, we can send message, we can send photos, videos, anything. We can browse it, we can use it as a mini laptop, right? So we can do a lot of things. If we are increasing the smartness, we can do a lot of things. The same thing. There is no limit for, there is no particular scale for anything for the term smart city, the smart. So if you are increasing the features and functionality, yeah, definitely it's going to be a smart. There is no limit for that. So smart city means like already the audience, some people mentioned like that. Everything is going to be interconnected with the sensor. Sensor, why we need sensor? Sensor means we are going to monitor, because smart means we are not going to do anything in manual ways. That's it, right? We are going to control, monitor everything where we are present. Okay, we are having our mobile phone, smartphone. So we are using that smartphone as the controlling medium, and we are going to control everything around us. That means our end is becoming smart. So the controlling end, that means the node we are going to control should be a smart one. Then only we can control it. So that's why we are fixing sensor in everything. Not only sensor, depending upon the smartness we are going to incorporate some new electronic devices or electrical devices or any IT solutions, anything we are going to implement in there. Okay, this is the exact rough outline of smart city. Like I already said, there is no limit for smartness. We can increase, if we are increasing the functionality in future, yeah, definitely we are increasing the smartness in anything. Here now today we are going to talk about more on smart city means it's more relevant to our lifestyle, right? How we can carry over our everyday life in a very smarter way, right? With our mobile phone, we can schedule our day-to-day life activities in a smarter way. Like we can set alarm, we can set reminder, we can put health monitoring apps. We are having a lot of apps to monitor our day-to-day life activities. So these are all only regarding our lifestyle. But regarding environment, where we are living with our surrounding neighbors and other living organisms, it should be a smart one, right? So the today topic is relevant to not only the self smartness, it is also the smartness going to be incorporated in environment. So this is the smart city. Okay, the topic is clear. Smart city is clear. Can you imagine what is the now? Till now we are talking about the only positive side of the smart city. Can you imagine what are the negative impacts we are going to leave when we are incorporating these type of smartness in the environment? Any negative impacts from your side? Any points?
Yeah, madam, regarding security, madam.
Security. Any other thing? See, security means, yeah, it's a negative point, but it's in the aspect of our human, in the aspect of human only, right? Human perspective only you are speaking. But
Yes, yes, ma'am. Actually, we'll be able to hack the data, no?
Yeah, it is about your more on implementing the technological side of the smartness. I am asking general aspect here. If you are implementing more smartness, that means more technological things going to be incorporated in the environment. What is the negative effect on environment, not on a personal life, privacy or security? I'm asking about the environment level or global level, like that I'm asking.
It's against the nature.
Yeah, against the nature. Till now, we are telling we are in the more advanced stage. We are in the more advanced age. We are doing a lot of things very advanced, very sophisticatedly when we are comparing with the our ancestors. But what we are leaving to the environment, what we are giving to the society, or what we are giving back to our society by doing these advancements in our technology or anything, research or anything, we are in the far more research, I mean, advancement in research, any area, but what we are leaving to the society, what we are left to the, leaving to the future generation as a resources, right? That is the big question. If you see, whenever we are inventing something very useful to the society, that usefulness is only lies in the word of society, but not actually. We are always focusing on the useful to the humans, but not to the society. We are always focusing on the benefits on the human side, not the environment side. The world is a compact pack of everything: human, animals, birds, environment, natural resources. Everything is should be in a balanced way. Then only we can live peacefully in an environment. Otherwise, it will create a negative impact in the society. So, okay. The next point is why we are talking about more on sustainable. Why the topic sustainable is becoming more hot topic in nowadays research. Any reason? We can tell new technology, right? Bitcoins, a lot of inventions, quantum technology. So a lot of things are happening in research, but everything is focused on one point, that is sustainable. Why?
Yeah, ma'am, because the population is increasing and the nature, the earth is also almost it's getting filled with people, and we cannot give anything for the next generation. The fossil fuels are getting exhausted, all those things.
Yeah. So, like you said, we already come to the conclusion with any advancement, any research innovations, we are going to some level, at any point, we are going to give a negative impact on the environment. So, now we are come to the conclusion with any research or any advancement and any technological innovation, it should be related or mainly focused on sustainable development. That means if anything is invented, it should reflect a result of sustainability. Then only it is a viable one for our future generation and also us. That's why nowadays we are speaking more about sustainable. So that's why the United Nations fixed 17 goals to slowly retrieve our Earth back to a normal lifestyle. That means that we are having 17 goals on different sectors. But today I'm going to speak on my research area is only focusing on, not only, mainly focusing on affordable and clean energy. So this is regarding UN SDG Goal 7. So before going to the topic, I'm just giving the importance of sustainability to everyone. Why we have to follow the sustainability in our day-to-day life. Then only we can, nowadays as a youngster, I know what is the stress and what is the, hectic life we are living in the society. Because if you are running behind, running behind a day-to-day life, you are running behind money means we don't have enough time to take care of ourselves, to take care of, to take care of our family and environment, anything. If we are self-satisfied only, then we can see others, right? So these are the issues faced by nowadays young kids. And also, if environment is also not environmental supply, that means resources and other things, if clean air is not there and clean water is not there, that means we are not at all eligible to live in a particular place. So we have to make our earth a sustainable one and a greener one. Then only we can live a stress-free, happy life. So it is very important to focus on sustainability to live a normal, basic, happy life. That's why we are talking about sustainability. So today's topic is relevant to smart cities. So when you are going for smart cities, what is the fuel of everything? See, the main fuel for our day-to-day life activities become an electricity, right? So energy is the first thing we are using. Energy is the majority thing we are utilizing in our innovations from our innovation side. So when you speak about electricity, without electricity, we can't do anything. Any sector can't run. Literally, I can say it. Because without electricity, we can't do anything. Like nowadays, all become smart means smart only possible if there is an electricity. That's why electricity is very, very important in all aspects, in all sectors. So for that, I'm starting from the very old historical period, how electricity is generated, why we are using meters, because my research is smart meters. So I'm going to relay my research results towards the sustainability. So I'm starting from the very starting point. So everyone knows after the generation, after the protection of electricity and utilization of electricity in mass way, there is a need for there is a need to calibrate how much electricity is generated. So that means after generation of electricity, we are using that electricity to the consumer. So what is happening? We are providing some energy or some goods to the consumer without money. So we need to pay, we need to, we need to give the electricity in a cost way. That means for some amount of energy, we have to cost something for the consumer. That's why we are going for meters. The problem is how to sell the electricity. In which way we can sell the electricity? Because if we are generating milk, then if you are having milk, we can sell the milk for 1 liter. Then we can cost that customer with 1 liter of milk. But when you go for electricity, what is the actual parameter to calibrate the electricity that we sell to the society or sell to the consumer? So this is the biggest problem in those days. That's why we are going for meters. So meters are invented because meters are invented to calibrate how much we are exactly consuming. So this is the most essential and basic aspect of the meters. But what happened? Meters are invented in different style and different method. They use different principles to calibrate the how much energy is consumed. So the outline is how much we used, pay for that and save money. This is the exact concept of meter, okay, on both utility side and consumer side. So in history, a lot of meters were invented. The main classification, though, from the starting date to till date, lot of meters were invented. But all the meters are classified into three, majorly classified into three categories. One is analog meter. That analog meter is nothing but if you go back 20 years back, every home is fitted with one analog meter, the advanced one analog meter. There's a mechanical meter. It is having a reading, wheel, which represents how much energy is consumed during the day. Okay. Then the digital meter. If you go back, nowadays we are using digital meter, right? Not because the smart meter is not installed in every part of the India. So most of the populations are using digital meter. Digital meter is nothing but the same thing, but we are going to measure the value in digital way, not in an analog way. It's a digital way. So it will give the exact value with the decimal value. For example, 4.5 kilowatt hour. So we can get the exact value. So this is the digital meter. What about the smart meter? Like I already said, if you increase the functionality and controlling ability of a particular thing, it becomes smart. That's it. We don't need to go to the exact location of the device to control it. If you are having that smartness in that particular device, we can control it from, we can control, monitor from it anywhere. So this is regarding smart meter. So this is the major classification of smart meters. But when you see back the history, a lot of meters were invented. Like these are the rough outlines of the historical invention of different types of meter. So starting from 1872 to 2000, a lot of meters were invented. Most of the meters are analog oriented one. In the later or early period of 2000 or early period of 1990, only digital meters were invented. That because then only that time only digital technology is invented. So every meter has plus and minus. That means positive sides and negative sides. So each and every meter is depicted by the new arrival meter, and it is also have some disadvantage. So because of that, new meters are invented. So like this, a lot of meters were invented in the past 100 years. So regarding, I'm now on up to this, I'm only talking about meters. What about metering process? We are having meters, but what about the metering process? What is metering process? Meter is fixed with, meter is fixed with one house. Okay, that's it. But what about the metering process? Anyone? Actually, my research is mainly focusing on smart meter, but later on, I'm very much interested in the metering process also. How we are metering it. That is very important thing, because for that purpose only we are inventing the meters, right? How to sell the energy. That is the primary question to invent these type of meters. So metering process is nothing but how we are reading the meter. That is the metering process. If you see the analog meters, definitely there one person from utility side. Or utility means I am telling about electricity person, electricity board person need to come to the place, home, house, consumer end, and check the meter for readings. So that is conventional metering process. Later on, one technology that is involved, that is AMR. AMR means automatic meter reading. That means it only give one-way communication. One-way communication means you can send the data to the utility end. Utility end means electricity board end. And hereafter I'm going to use the word utility end. Utility end is nothing but the electricity board end. Okay, so it automatically takes send the reading to the utility end because of the communication technology development during the 90s and 2000. Meter can itself send the data to the utility end. Then after 2000 and 2000, after the 2000 and 2000 up to this period, we are having a lot of advancements in communication technology, IT, lot of things are happening. Because of that, we are having one term that is called advanced metering infrastructure. It is not only, not only on meters, it is also the infrastructure which is going to help the meter to become an advanced one. That's why it is called as advanced metering infrastructure. Then we are going for smart energy meter. See, these are all some conventional method. These are some flow, conventional flow I'm telling you, but there is no actual distinction between AMI, smart meter. So we can understand if we are, we can understand smart meter in different way, because if you see the smart meter, there is no limited functionality or there is no standard. If this is the smart meter 1, if this is the version 1 means it should have this type of functionality and it should have this type of standardization. There is no hard and fast rule, because if you are every meter, every seller have different functionality in different meters. So smart meter is a common term used for making the meter as a smart one. So this is regarding the evolution of meters from meter and metering process from historical period to this period. Okay. So this is the same 8081 electrolytic meter is identified, 8084 pendulum meter. Electrolytic meter means it's a chemical reaction oriented meter. Pendulum meter means it is based on the oscillation caused by the pendulums. And motor meters, yeah, dynamo is invented, because of that motor meters are also invented. Induction motors, then digital meters, then remote meter. Remote means what is the meaning? From the place itself, we can get the reading. If I am the ED person, I need to calibrate some person house means I can get the reading from the office itself. I don't need to go to the consumer end to take the reading. There is a remote reading. With some advancement in that remote metering, it becomes smart meter, because not only I can take the reading, I can control the consumer end from my side also. If I need to, for example, if I'm telling the consumer has not paid the monthly bill, I need to cut off the supply from their end means I can do it from my office itself, PV office. I can do that. So we can add any functionality, any smartness in that meter if you are programming that meter, and if you are providing the enough infrastructure to the meter, it becomes smart. So this is the evolution of meters from the 1881 to present day. So okay. Apart from smart meter, one important term I have to introduce, already you know, but I'm telling the new word that is called a smart grid. Okay, smart grid. What is smart grid? We are in India. The meter in India, we are using a traditional grid, electrical grid. Hold on. So we are using one electrical grid. Sorry, in India we are using traditional electrical grid. That is more conventional. That is, we are using all the electrical generation, transmission, and distribution in a more conventional way. Okay. What about smart grid? Smart grid is nothing but. Are you able to hear me?
Yes, madam. Yes, madam.
Yeah,
We are
yeah.
able to.
Okay. Okay. So smart grid is nothing but the same thing. We are going to implement the smartness in grid also, then it becomes smart grid. So don't dig for a deep meaning for everything became the smart. Smart, we can customize it however we want, and there is no limit for it. If you are having basic electrical grid, then if you implement some, like already some audience said, if you are implementing the sensors and controlling units in all the ends of grid, then it becomes a smart grid. Okay, from the starting from the generation to the consumption, if you are making everything as a smart, then it becomes a smart grid. Okay, why we need smart grid? What is the main purpose of smart grid? If you see in India, not in India, if you see the electricity generation aspect, we are generating more. Sometimes we are generating more rather than utilized, because we don't know what is the actual consumption, right? We don't know what is the actual demand for a day. Okay, so we are predicting the demand before by using the past data, right? That's why there is always an imbalance in generation and demand, supply and demand. Supply means generation of electricity. Demand means consumption of electricity. So if we want, like already sir explained, we are in the stage of extinction of all fossil fuel. So we are not able to focus on new, it is there, but the research has to be made more vigorously in order to develop new energy resources. But if you are speaking on the other end, we can conserve our energy by using that energy in an appropriate way. That is energy management. So if you are able to conserve energy by using this energy management, then we can easily avoid these need for the new resources. Okay, that means if you are able to use the generated energy as a full, then it is a efficient one, right? So we need to, in order to make that happen, we need to balance the energy supply and energy demand. So in order to make the balance, we need to know what is happening in what is the real-time scenario happening in the grid. That perspective is very important, because if you are able to understand what is happening in the grid in a real time, then we can easily generate and we can easily distribute the energy, right? So for that only, we need for that only smart grid concept is introduced. Not only for this aspect, the main aspect of smart grid is nothing but we need to balance the supply and demand, because in order to make that as a working one, we need the real-time monitoring. Real-time monitoring is only possible if all the nodes connected with the grid become smart. So all the nodes are connected with the grid become smart, and grid becomes smart grid, right? So for that purpose, the smart grid is mainly introduced. The next thing is, the question why we are going for my research is smart meter, and also it's an affordable smart meter. That means we already know we need to make all the ends, all the nodes in the grid to us smart. So if you are seeing on the distribution side, substation side, all the ends are connected with the different devices. We have to make the devices we have to make the device as a smart one. But when you see on the consumer end, the one device which is connected with the utility is smart meter, right? So, not smart meter, it's a meter, electric meter. So we need to make that meter as a smart one. So that is my core research area. I'm going to use, I'm going to, in my, the broad idea of my research is smart meter, but the implementation style is different. It is mainly suited for developing countries and countries like India, and we can make the smartest with optimal cost. That is my main research area. Okay. Yeah, real-time monitoring. I already said real-time monitoring is very, very important when you go for smart grid. Without real-time, that main purpose is real-time monitoring, right? How much energy is generating, how much load is occurring in the particular feeder. Anything we want to monitor, it can be possible by smartness. Okay, now I'm going to introduce the actual meaning or generalized meaning of smart meter. But if you go around with resources and source around the net and any other book, smart meter has different meaning. But the most generalized one is it can communicate in bidirectional way. That means it can tell to the utility end what is happening in the consumer side, and also it can convey the information or control signal sent by the utility provider to the consumer. So it can communicate in bidirectional way. That means our meter can be able to speak to the EB. And if EB is sending something, now that meter can convey that information to the consumer. So this is the broad outline understanding of smart meter. Okay. So data is flow between in a bidirectional way between consumer and utility provider. So this is regarding a smart meter. Okay. These are the information I already shared with you. Then now I'm going to explain what are the benefits of smart meter. Benefits of, if you are speaking about benefits of smart meter, like I already said, apart from substation distribution, apart from other utility, other EB areas, the more nodes are distributed in grid is consumer end. So we need to make the consumer end as a smart one. If you are able to make the consumer end a smart one, we can do a lot of things like energy saving, demand response, reduction in CO2 emission. That is very important. And remote monitoring and automatic billing, and reduce the metering costs and transportation costs. Yeah. By so now you can understand we don't need to go to consumer end to take the reading. That means transportation cost is reduced, and also metering costs, because we are because we are utilizing the human resources for metering the particular houses, and we are using vehicle, we are giving vehicle to that person to go there to take the reading. So we can avoid that cost. And also, if you are avoiding that type of transportation, we can easily avoid the fuel consumption or unwanted work. So we can easily reduce the CO2 emission in the environment. So the main purpose is remote metering. Smart meter is the basic main purpose is remote metering. By remote metering, we can reduce the transportation and also metering cost. Why? Because of this, we can easily avoid CO2. Because for each and every trip has consuming some fuel. If you are able to reduce that fuel consumption, then CO2 is reduced. See, the smart grid concept is indirectly relevant to all other aspects of sustainable. It's not only smart meter, smart grid is indirectly or directly is creating a lot of impact on sustainable environment. That's why I'm saying energy saving. Energy saving means we can save energy, because if we know the demand and if we can generate that much amount of energy. Remote metering, like already said, there is no need for go for consumer end, and also automatic billing. There is no time is up for time and human resources. You are the bill preparation is enormous nowadays. But if we are implementing smart meter, automatic billing is possible. So these are the benefits regarding smart energy meter. The term smart energy meter and smart meter can be used as a global, because smart energy meter is more technical word. Smart meter is the more commonly used word, because smart meter is not only used for energy purpose. It is also used for water, gas in foreign countries. Here in India only we are selling, we are having the, we are metering the energy only, because waters and other things are, we are having different resources. But when you go for foreign countries, gas, water, and electricity, both are metered, because both are given by some distributor. Because of that, they are metering collectively. That's why we can use smart energy meter specifically, but on a broad spectrum, we can use smart meter. So this is a conventional metering. One person comes to home and takes the reading for every month or twice a month, depending upon the scheme of that particular electricity board. But when you go for smart metering, there is no need for coming to the consumer end. You can easily get the reading by using smart meters through the bidirectional communication, right? So this is smart metering. When you see back the history, there are different type of metering is there. First one is manual reading, like already said, person come to the home and take the reading. Then AMR and RMR. RMR is remote meter reading and AMR is automatic meter reading. In both reading, they use one directional communication. That means meter can send the information to the utility provider only. That type of metering process is tested and implemented in some part of the world. But due to the advancement in IT after the 2000 and 2000, after the period of 1990 and 2000, bidirectional communication is also involved. Bidirectional communication is incorporated in the metering process, so it becomes smart meter. Okay, so this is regarding the importance of smart grid. Already said, smart grid is very important. We are generating, we are distributing and consuming it, so we have to make it as a efficient one. Then only we can save our energy. That's why we are going for smart grid. These are the up to now. I only talk about the historical records. Now I'm going to explain the actual implementation of smart meter. That means the first smart meter project happened around worldwide. So if you see the data, a lot of things are happening. Canada, USA, Germany, Belgium, Australia, Ireland, France, Italy. In India, they started around 2011. Smart Grid Task Force. By using that, under that body, we are implementing the Smart Grid projects from 2011. So every country started that project. If you see the data, Italy is the first country. I think so. Italy is there. It's the first country to implement the smart meter project. So around the global, lot of countries are nowadays it is more, but these data are the first project they take it. Okay, first project is implemented by different countries. When you see the scenario, this is taken from long back. It's actual data, up to 2017. So China is in the leading stage to implement the smart meters. After that, United States, then Italy, and then Japan, and then Spain, and rest of the world. So these are the participations of countries for implementing the smart meters in their country. So this is regarding the smart meter pilot project happening in India only. So these are the data is collected from at a government portal. So if you see the map in a lot of places of the country, smart meter pilot projects are happening. It's not happening in a whole way, because when you see the smart meter, in my research, I found that there is no standardization. In architecture way or communication way, there is no standardization is there. Different countries follows different methods and different standards, different technological design. So there is no standard way, there is no standardization to develop a smart meter and to use a smart meter. So every smart meters are tested in a pilot project. If you see in Tamil Nadu, one ongoing project is there by Tangenco, and then Puducherry, Telangana, Odisha, Bihar, Assam, Tripura, West Bengal, Andaman, Karnataka, Rajasthan, Gujarat, Haryana, Chhattisgarh, and Delhi. So these are the places, the ongoing projects on smart meters. Now, not only, see, lot of projects are happening around India in smart grid, but the project mostly relevant to smart meters. I took that data only and presenting the data only to you. So this is only regarding smart meter, not smart grid project. So yeah, finally we are coming to my research. In my research, the first problem is it possible to, because if you are increasing the smartness, it is at the cost of purchasing cost, right? So if you are going for a more smart phone means, I mean more future smartphone, more features are in a smartphone means the cost obviously going to high. Okay, so is it possible to get all the benefits and future with the minimal cost? Right, that is my research problem. Is it possible to give a smart meter in a very affordable cost? That is the main research problem of my research area. So if you see the existing smart metering architecture, each and every houses should be attached with one smart meter to make a grid as a smart one, right? So each and every person need to purchase one smart meter to make his home as a smart one, or to make the grid as a smart one. This is the actual scenario happening in the majorly happening in the worldwide. So all the data are collected by DCU. DCU is nothing but data concentrated unit. Then it is transferred to the utility head-end system, head-end server. So where head-end server is the main area where all the data are collected from different DCUs are stored. Then from that server, meter data management system going to take the data for different management program like SIS, this. So different, we can see. If you see the communication layer, application layer is the top one, right? So we can use different, use it for different purposes. If we are having data, we can use it for different purposes. So that different applications are handled by meter data management. So for that meter data management, we need the data is taken from head-end system. So this is the actual scenario of the architectural scenario of the existing smart meter. But my proposed idea is why we need to place a new smart meter in each and every houses. The optimal aim of smart meter is going to communicate. It's going to speak in both directions. That's it, right? So we can make the existing digital meter by incorporating some add-on devices with it. We can make it as a smart one. This is my research area. See, because If you are able to provide a single meter, that means I'm going to place 1 meter. That meter can control all the meters present in a group of houses. For example, in a street, 5 houses are there. That 5 houses can be monitored by a single devices without replacing the old meter. This is my proposed area. But existing idea is all the 5 houses should be replaced with 1 smart meter to make it as a smart. If you see here, the existing meter, home 1, home 2, home 4, up to home 5, all the meters are connected with the DCU. Then from DCU, it is connected to the utility server. But my proposed idea is all the existing meter, that is digital meter, is added with 1 device, which make that device, which upgrade this digital meter as a communicable one. Okay. But from that, I'm going to take the data from all the houses and process the data locally. Okay. This is the local device. This is the developed device. It's going to process all the data collected from the different houses. That means group of houses, cluster of houses. Okay. And also, if you see I introduced 2 terms. One is meter and another one is metering process. This is regarding this is regarding meter. What about metering process? If you see the metering process, nowadays all are in centralized way. See, all are in centralized way because all the data are collected to DCU. DCU is placed for a particular area. I mean, for a particular feeder or particular substation, depending upon the limit of houses connected with the DCU, it is placed there. So from the DCU, the data is collected to head-end system. From head-end system, it is taken by different management system. Okay, this is the actual scenario. If you see the metering process, not only meter, if you see the metering process, it is in the centralized way, right? Everything we need for every process and for every controls, controlling features, we need to rely on head-end system, right? Because that is the main area of all the data collected, because that is the main area for the utility, since it gather all the information from all end of the grid. So metering process is always in centralized way. So in the another research, another points I'm added with my research is decentralized metering process. That means I already developed 1 device. That device can handle group of houses. That means 5 or 10 houses. That means I can meter that 5 houses decentralized. Why I have to depend on every time on the centralized head-end system? So these are the 2 problems. That is cost. I'm going to reduce the cost because there is no need for purchasing the new meter. That is the first thing. Then I'm going to reduce the traffic, data congestion, the network by making the metering process in a decentralized way. Okay, these are the 2 main objectives of my research. So actually, if you see the smart meter design, the smart meter design mainly consists of 1 controller, because smart means we need to make in the cost of controller, right? Controller. It's going to control everything. Existing smart meter have current sensor, voltage sensor. Current sensor read the value, voltage sensor read the value, and it is giving that value to the energy measurement IC. That energy measurement IC calibrate the energy measurement and it giving to the microcontroller. From microcontroller, that that microcontroller will send the information to the server by using the communication modem. So this is the actual design of smart meter, smart energy meter or smart meter. And also the data, we are communicating the data to the central server, right? But around the globe, different countries follow different topologies to receive the data. Sometimes they send the data to the DCU, and from that they can get the utility data center. Then some countries will have some other gateways, and they transfer the data to the substation. From substation, it is going to data center. Some other countries directly have different communication also used. Different communication topologies also used. Most of the countries now in last 10 years before, they are mostly involved in PLC. That means power line communication. Nowadays, they are using cellular and RF communication. So optical fiber is also one thing. So a lot of architectures are going around, happening around in the global. So it depends upon the country where the metering, smart meter is implemented, because the communication is mainly rely on geographical condition, and also because data loss is the main thing, right? So it is rely on different factors. So different countries follows different architecture and topologies in communication systems. If you see the communication system, mostly, see, I'm talking in a broad and in a very peculiar way. See, design of smart meter and the communication they are using. The two area I'm going to analyze, and that from that analysis, I'm going to take one architecture and one communication for my research. Then from that research, what are the outcomes I received? That thing I'm going to introduce to you. But at the end of the research, smart meter benefit is mainly for sustainable environment. Okay, so regarding communication, like we already know, wired communication, wireless is there. On smart meter, we are using PLC, DSL, fiber optic, and wireless, we are using Zigbee, cellular technology, WiMAX. These are the broad classifications. Different Z wave, LoRa. Nowadays, they are using LoRa for more communication, but sensor nodes. So different communication technologies are there for smart metering. So if you see this data, these are the different countries using different technologies. USA using RF WiMAX, cellular, Zigbee. China use cellular and wireless. If you see on wired, most of the countries use PLC. What is PLC? Power line communication. We can use our energy line, that means transmission power line itself as a communication medium. So a lot of results are happening in PLC. But on the wireless side, cellular is the most prominent one, because it is having more coverage area in more countries. You see the India cellular tower is present in every area, because we are using mobile phone in every area of the country, right? So that communication is the most viable and optimal one for India like country. So that because of that only, the most population and most geographical oriented country use cellular communication. So choosing the communication is totally depends upon the policy of country and geographical condition of that country. This is one paper. See, regarding this is the data, literature data I collected. See, I'm not going to tell all the authors, and I'm going to who are all invented other things. So this is the whole data set I collected for my literature to justify the design aspect, to justify my proposed work in the design aspect and communication aspect. If you see here, the main concept I'm going to take is data routing destination. If you see, all the researchers are designing the smart meter to route the data. Route means transferring the data to such a particular end. If you see, rear end, data aggregator, utility server, control station, remote station, main server, server cloud. So all are based on centralized. That means all the data are going to pull to central server. So my concept is why we have to rely on central server. Okay. If you make that question, the answer is we need to control and monitor, right? If you see the benefits of smart meter, the actual benefits for with the smart meter is not on consumer end. If you want to make it as on consumer end, you have to make the entire grid as a more reliable one. Okay. But if you see on the utility end, we are having a lot of benefits, because they can control the grid, they can monitor the grid. Lot of things are happening on the utility side. So if you want to make the full benefits of smart meter on consumer end, you have a decentralized processing, because you have data. With the data, what the main functions you are going to incorporate: billing, monitoring, then demand profile making. So these are the things you are going to make. If you see the benefits, you can classify the benefits of smart meter on two sides. One is on consumer side, another one is utility side. What I need to say in my research, the consumer benefits can be decentralized. The consumer benefits and controls can be decentralized. Why we have to rely on the centralized one? The centralized one is for utility purpose, and the decentralized one, that is my proposed network enabled smart meter, can do the decentralized processing and can answer the consumers and can view the information what they are consuming and when they have to pay the bill, how much they are consumed, what is the energy profile or consumption profile. All the things can be locally generated and can be delivered to the consumer. There is no need for approaching every time the centralized server to answer the consumer end. So if you see the benefits, a lot of benefits on smart grid. The main benefit is consumer information system. Okay. So this is decentralized in my proposed area. So regarding this, I'm going to take all the data are routed to server, but in my research, this is consumer information and consumer oriented data can be processed and answered in the NASEM itself. NASEM, Network Enabled Smart Energy Meter. That is a name given for the proposed area, so that meter can answer decentralized. So this is the concept. Then bandwidth. Bandwidth means already said, if you increase smartness in the grid, the main.
Elil,
Sir,
Elil, just a minute. Hari, are you here, Hari?
Yeah, yes, sir, I can hear.
Hari?
I can hear, sir.
No, okay. Hari Syed is there?
Yes, sir, Syed also there, sir.
Okay. Hari Syed, in the end of the program, you will put on Google form for the certificate. Okay.
Yes, sir, already done, sir.
Done. Okay. 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 And so now Elil is presenting. After that, any presentation is there?
Yes, sir, Mahita ma'am need to present, sir.
Okay, right. Okay. You can ask, you can put in our IEA and NCA Club group and some other members to come and join.
Yes, sir, we have already posted, sir, but no one joined, sir.
Again, you
Yes,
tell
sir.
all. Okay.
Yeah, okay, sir.
Continue.
Hari?
Continue.
Yes, Hari, can I ask one question? How much time I left for my slot? Hari,
Yeah, ma'am.
how much time I left for my slot?
Ma'am, it's almost 2 hours, ma'am. If you are going to do 1 hour.
Okay. I will make it fast. Okay. So this is regarding the bandwidth. Bandwidth.
Ma'am,
Yeah.
you can go slow, ma'am.
Yeah,
Till
slowly.
8:30. Yeah, 8:30.
Up to 8:30.
Yeah.
Now, what is the time?
Now it's 7:54, ma'am.
7:54. Okay, I can go slowly. Then means so I already explained the architectural concept of my proposed design. Now I'm going to do another aspect, the benefits of my proposed design. If you see, I already told you centralized is going to be converted as a decentralized in my proposed area. The other benefits in achieving the decentralized is nothing but data traffic reduction. If you see the centralized architecture, all the data from not only meters, all the nodes associated with the grid sends the data to the centralized server. What is happening? Data, millions of data, millions of bytes of data are going to approach the central server each and every day. Okay, if you see the normal design of smart meter, it sends every 15 minutes the reading to the central server. Similarly, all other smart nodes in the connected in the grid will send the data to the smart central server. And also, like already the two persons explained how the renewable energies are important and how they are incorporated in the grid. So these will make more data to be sent to the central data. So and also the other aspect is, like already you see the communication aspect, we are using cellular. Cellular means it is mainly used for media, video, all of the communications are rely on cellular only, right? So if you see the smart grid, it's going to take a smaller bandwidth, very minimal bandwidth going to be allotted for smart grid communication, because the data going to be sent to the central server through the cellular communication going to take very minimal bandwidth. So we have to utilize that minimal bandwidth in an efficient way. If you make all the process in a centralized way, what is happening? Every time you are approaching the server and also every time you are uploading the data, it will make bottleneck the communication network and it will result in lot of reverse side. That means data loss, data error. These are the happening in the because of the centralized processing. And also the term nowadays we are using to call that data, big data. That is big data means how much data we are going to handle in near future. That means it's a big one because nowadays all are become data, right? Everything is become data. With the data, we can do anything. Okay, so that is the main purpose. The next one is if you see AWS, AWS, they are released one notice that is they are also in the process of metering data analytics. They insist on the concept of decentralized customer information system. So if you make it as a decentralized one, then it is more beneficial one. So based on this, I'm going to take two things. One is a common meter for group of houses and decentralized data processing in order to reduce the network congestion. These are the two optimal aim of my proposed work. So if you see billing updates, blackout update, consumption update, in-home display, and IHD is nothing but in-home display. In-home display means it's a device which is fitted in the house. It is a graphical interface which can interact with the consumers in a graphical way. How much they are consuming, like a graph, like an indication. So that is the in-home display. So these are all systems. That means customer information system only for consumer. But if you see on grid monitoring, demand management, outage management, operation management, grid automation, for this we need certain data. So we can classify the data in two categories. One is for consumer, another one is for utility provider. So if we are able to make the consumer side data to be processed locally, then we can easily reduce our network congestion. Okay. So from all the literature works and the data and historical data, all the resources I collected and come to two conclusion. One is all the work insist to play the smart meter in each and every home. So this make increase in cost. Deployment cost will be increased. Then utilizing the existing metering infrastructure. That means digital meters to use the existing metering infrastructure for smartness is very less. And also data traffic. So these are the serious problem and the knowledge gap I identified from my literature work. Then I'm going to design, I'm going to model. Okay, then I'm going to model my proposed idea. My proposed idea is I'm going to design a network enabled smart meter. That is, meter can handle group of houses. So here it is having 5 houses. It is for pictorial representation. So here 5 houses. This 5 houses is handled by single smart energy meter. That is network enabled smart meter energy meter. But here these 5 houses are connected with the DCU. Then from DCU to it is going to central server. So if you compare the benefits of NASM, it is less deployment cost because if you see each home is fitted with 5,000 cost. Smart meter means 10 houses. How much it is cost? 5 lakh, right? Sorry, 50,000. 50,000, right? Similarly, if you go with NASM, here the cost is reduced because for a group of 5 houses, we are going to place only 20,000 cost 1 meter. So all the benefits are going to be achieved by NASM itself, but the small deployment cost. Then maintenance cost. If you are increasing number of nodes, obviously you have to maintain the nodes, right? You have to update the hardware. You have to make firmware update, hardware update, software update. So every time you have to approach the houses, or you have to remove the old meter, or you have to, if you are going with the firmware update, means you can release it from cloud itself, or you can go to the consumer end. So every time you have to approach the consumer end in order to do the either hardware or firmware or software update. But when you go for NASM, it can be done for 50 houses or 10 houses in a centralized place. And also replacement of old meter. Every time consumer can afford to purchase a new meter. But when you go for NASM, for 10 consumer, if you are inventing a new meter, version 2 means everything is replaced in the everything replaced in existing. But if you go with NASM, you can replace that 1 meter, which is common for 10 houses. And also network congestion. I already told you because of centralized processing, network congestion is happening more. but in proposed work, network congestion is less. And also dumb node. Dumb node is nothing but you see smart meter. Yeah, we can speak smart meter, but we can't force all the consumer to purchase a smart meter in each and every home, right? It's their willingness to purchase smart meter or not. So if any nodes are left out, if you see in a feeder, 1,000 houses are connected, only 800 houses are connected with smart meter, remaining 200 houses are not connected with the smart meter. Means what is happening? You can't get the full benefits of a smart meter, right? Smart grid, because some nodes are left out from the monitoring and controlling. This will create a huge problem. So you have to make all the nodes as a smart in an affordable cost. That's why we are going to utilize the existing digital meter to make it as a smart meter. It is very easy, right, to make this concept as a workable one. So this is the comparative analysis of benefits and analysis of existing meter and smart meter, the proposed network enabled smart meter. So in order to come to conclusion whether our proposed idea is the optimal one and viable one, we conducted one survey, consumer survey. So for that, we formulated a series of 10 questions which can easily understand by the normal people, which will create the results of that survey will create a great impact on our conclusion. So the first, see, these are the series of questions, but I will show you the very important questions only and the results obtained for that question to you. So I broadly classified the questions into 3 sectors, that is the persons who are not know what is smart meter. The another category is, yeah, they already know, but they are not having the smart meter with their home. The other person is already having smart meter and they are using that smart meter in their daily life. So I classified that consumer into 3 different categories and providing some questions and getting answer from them. So if you see the results, so this is a question to analyze the pattern of the consumers. How many of they are living in single bedroom and double? This is for analysis purpose. And the main question is, do you want to know how many units of energy utilized in your home regularly to reduce monthly electricity? This is the main question because this is the main application of smart meter, right? So if you are asking the question, 91.8% of the people are interested to know real-time monitoring. So this is the first result that, yeah, smart meter is very important for this society. This is the first result. Then our idea is we are going to utilize the existing digital meter to provide a new proposed NASM, right? So we have to check whether all the houses are fitted with the digital meter. You see 79.5% of people are having digital meter. And also these meters are soon going to be converted because of the government rules and policies. And also the another question is National Electricity Board plans to change all the installed electricity meter to a smart meter with estimated cost of 4,000 to 5,000 for a single phase and 8,000 to 9,000 for 3 phase. This is for cost analysis estimation. EBs plan to change all the meter to smart meter and the cost is like this means, are you willing to change? 70.3% people are saying yes and 29.7% are not saying no. And also we introduced our proposed work. We are proposing our concept to the consumers to get the answer whether you are okay with that. We propose a new centralized meter called an ASM, which can act as a common meter for a group of houses. With the ASM, electricity board can individually, because if you are going with the concept of common means, they are in the fear whether some people can, some other houses bill can be put in our head, like that they are fear like that. So we make that question clearly, can individually read every house electricity bill without replacing old meter. So while raising the question, some dilemma is there because if you see no idea. 34 point, because if you are telling something technically to a common people means it will take some time to reach, right? And also the understanding level is differ for a common people. So 34.3% are telling no idea and 31.6% is giving the yes answer to proposed NASM and 30% is giving no, because most of the person giving no because They fear that their bill can be shared with the other person, or other house's bill can be shared with us, I mean, on them. So because of that, they are telling, because we asked the reason, we get back the reason. If you are telling no, what is the reason? They stated that it's a common meter, so there is no, I mean, guarantee to that bill is correct, like that they are telling. After that, we made one question on the basis of cost, like which one of the following two options you can get all the metering functionality, which one do you prefer for your house? We are giving two options. One is by connecting one add-on device to the old digital meter with an estimated cost range from 1,000 to 1,500, and by replacing the entire meter to a new meter with estimation cost of 4,000 to 6,000. That time people answer 73.4% for the proposed idea. So from this analysis, in India, from the survey, most of the people are concerned about cost. So cost is the prime factor, because we can't force all the consumer to purchase a costly one. So cost is the prime factor. I took the cost as the prime factor for my research from the survey. Then, yeah, we created the idea, we get the results from the survey. Now we are going for implementation and design model. So for that, first we patent that project, and also we applied for funded project. These patent and fund is happening in the later stage of my research. But why I'm telling now, because that funded project, I developed the real-time hardware for my proposed work, and also I patented that proposed idea. That's why I shown here this detail. So this is the design methodology. I'm going to design one add-on device which makes the existing digital meter as a communicable one, and the NASM, which is a common meter. It can handle group of houses for a local metering, decentralized metering. So like already said, any controlling unit will have a controller, microcontroller. Then digital energy meter, microcontroller, Zigbee. During the early stage of my research, I took Zigbee as the primary communication, wireless communication with them. But when I implemented in real time, I use LoRa communication because it's the more optimal one. So microcontroller going to retrieve the data. How it is going to retrieve the data? The digital meter, from the digital meter, I'm going to read the data through RS-485 communication. Through RS-485 communication portal, and because that meter is having that portal, I can retrieve the data from the holding registers, because each and every digital meter having holding register to keep the value. From that register, I'm going to retrieve the data to the microcontroller. From microcontroller, it's going to send the data to the central NASM. In NASM, it has a main microcontroller. It's going to collect all the data from different houses. It is having one GSM model, Zigbee coordinator. In my real-time hardware, I'm having LoRa coordinator and one display and local storage and router. Router is for routing data to the central server. So these are the rough outline and modeling of the proposed design. If you see this GSM model plays a huge role in decentralized process, because if I am a consumer, I need to know how much energy I'm consuming right now. Means I can send the SMS, because most of the people not having a smartphone. Yeah, most of the people are having, but still a lot of people are using conventional mobile phone like Nokia, Samsung, like that phone. So they can get the information through message only. So message means any person, more educated people are using smartphone. If you are not educated, they are having simple mobile phone like Nokia, Samsung. So in that, if you want to know the message, if they can get the message by using GSM model. Microcontroller is mainly for processing the data, collecting the data, and sending the data. So for controlling process, I'm using microcontroller, and Zigbee coordinator. In real time, using LoRa coordinator, it's going to collect the data from different houses. This is the main architecture of the proposed design, and this is the actual architectural design. I'm having Arduino for testing purpose. With that funded project, I tested each and every part of the proposed idea. So first part is add-on device. In add-on device, I used Arduino. It is a microcontroller, and RS-485 to read the digital meter, because digital meter is having RS to Modbus communication protocol. So I'm using that communication protocol, and I'm retrieving the data from digital meter to the Arduino. From Arduino, I'm going to communicate to the central NASM using LoRa communication, wireless communication model. Then this is the proposed nasal design. In this nasal design, if you see, three models are mainly used. One is GSM, another one is LoRa receiver, another one is Node MCU, and another one is Arduino Mega. Arduino Mega is the main part. It is microcontroller part. LoRa receiver is mainly for receiving the data. LoRa have one ability which can act as the coordinator, aggregator, and node. So it can collect 10 houses data and route the data to this server. If you are programming all other nodes, that means these this is one add-on device which is connected with one home. So similarly, in this way, we can have 5 different add-on devices in 5 different homes. So each and every home is considered as a slave. And this is the master, Nathan is the master. So the entire architecture is going to work in a master slave configuration. If master asks something, slave will answer. If slave is needs some information, it can ask the master. So in this way, it's going to work it out. And Node MCU is mainly used for local server purpose, because I'm going to pull the data in a local server for visualization. I'm using Node MCU. And DSM is for mobile communication. So these are the model I incorporated in my NASM. So actually, the first phase of my work is completed with the simulation, then goes with the real-time implementation. So this is the result this is the scenario I simulated in the software, Proteus software, is because Proteus can do many microcontroller project, because if you say Arduino is the playable grid, right? Every people like college students, ME students, PhD students, all students are doing a lot of projects on mini project or main project. Everything are dealing with Arduino board. So Arduino is the main component, but every time we can purchase Arduino board and we can't do the test. The thing is not possible. That's why I searched for one platform which can virtually implement the Arduino. So I choose this Proteus because Proteus support the virtual implementation of Arduino. If any people or any students want to do some projects in Arduino, before going with the real-time hardware, you can choose Proteus as the simulating platform where you can get any model, anything, because apart from inside library, some outside library also incorporated in that Proteus software. So you can do all the designs in simulation. Once you get the result, you can go for your hardware implementation. So that's why I choose the Proteus. In Proteus, first I designed the add-on devices with the SIGD. So because during the early stage of my research, I stick with the SIGD. But now I use in real-time hardware, I'm using LoRa as a communication one. This is the central NASM for 5 houses. But here I'm using 5 Arduino Uno because of software constraint. In software, we can't make a virtual communication port. That's why I see here we have to make the communication between 2 different nodes in wireless way using virtual communication port. That's why it is having 5 Arduino Uno. But when you go for real-time implementation, you can get the same result with one single Uno, a Arduino Mega. So if you see the results from the simulation, remote metering, what are the readings read by the meter that is reflected on the meter, the central NASM. Okay. So this is regarding results for different meters. And this is for consumer notification. See, if you see, I'm using the GSM model. In GSM model, if I see, if I send the request, it will tell the answer to kilowatt hours used, 7 kilowatt hours used. I'm programmed very simple functionality to check whether it is working or not. But when it comes to real-time hardware, I can increase the functionality in future. So this is the real-time implementation after getting funds from AKC. DST fund. I received one DST fund, which is 2,50,000. From that fund, I created proposed the prototype. Proposed the idea in the form of prototype, not actual product, in the form of prototypes. Initially I checked with the 3 meter, and if you see the video, this is the real-time monitoring of 3 meters. So I hope you can get some clarification from this. So each and every meter is fitted with a different add-on. This is one add-on devices, and this is the central NASM. The LoRa model is there, and these are the 3 different meters. Actually, in real-time scenario, it is going to be fitted in 3 different houses, and everything is connected and programmed in a way which will reflect the data in a local server, which was generated by the node MCU. So this is the data. Apart from that, we are having mobile intimation also, mobile communication is also there. That means if you send some controlling commands to the NASM, it will automatically tell what is the energy consumption is happening there. Not only energy consumption, we can take all the data. What is the three-phase current? What is the three-phase voltage? We can retrieve all the data. But during my research, I only tested this thing. I need to develop all the things because this is the early stage of the research. I only retrieve the data from the holding register, that is energy consumption. So we can get the data like this. Here I use the single mobile phone for getting all the data. But for when you go for different consumers, it is programmed in a way for the consumer. This is the command, controlling command, like that. So this is the screenshot of the local server. That is Node MCU will create a local web server portal. In that portal, data will automatically pulled each and every time. So if you see here, it is the timestamp. Here that is home 1, home 2, home 3, home 4, 4 energy meters readings are automatically updated. So this is the graph drawn by from reading a one-day profile. I took all the one-day profile and plot the graph for 1 AM to 9 AM. We can use it for load profiling, all the purpose for this thing we can get. So this is the data, we can create a lot of things. Now, primary objective of my results is the first one is idea formulation, the next one is simulation, the third one is hardware. So with that hardware, I finalized, yeah, this idea can be implemented. After implementation, I need to do analysis. That analysis is two different parts. One is cost analysis, another one is data traffic analysis. If you see the cost analysis, I took 3 cases. One case is a flat, another case is street, and another case is villages. Because the distribution of houses is different in 3 different cases. Flat means it's a horizontal stack of houses. If you see the street parallelly, it is distributed. If you see the village, houses are more distributed. I mean, and the distance between one and different houses are more, right? So in case 1, I took 60 houses, a flat with 60 houses. So it is identified near Madurai, Chennai locality, which is in Chennai itself it is taken. So if you see the analysis with the existing technology, that means 1 smart meter for 1 home, but by using that concept, the cost is 2,40,000. But with the proposed idea, 92,000 is to the cost for monitoring all the 60 houses. If you see the second case, a street with the 40 consumers is selected. Out of that 40 consumers, 35 consumers are verified they are having digital meter. If you plan for a smart meter in that case, the cost is 1,45,000, 1,40,000. With the proposed idea, it is 56,000. The cost is reduced up to 60%. In previous case, it is up to 62%. You see the village, in village, 346 houses are identified. In 346 houses, 300 houses are fitted with digital meter. So if you do the cost analysis with the proposed idea, it is 2,61,500 rupees. But when you go with the proposed, I mean, existing idea, it is 12 lakhs. So if you see, if number of houses are increased, the cost reduction is also increased. You see, in 3 cases, 78% is the highest cost reduction. So if you go with more houses, the cost is going to be reduced. So this is a comparative cost analysis. When you see the data traffic, I already told you data traffic. This is the existing scenario. Each and every houses are connected with the DCU, right? The DCU sends the data to the central server head-end system through the cellular communication or any port, any communication medium. After that head-end system, we are going to retrieve data for different management purpose like consumer information system and this geographical information system, OMS, outage management system, DRMS, demand response management system, and meter data management system. So for different management system, we are rely on head-end system because head-end system is the central server for all the data, right? So if you see the data, I took 1 million consumers for analysis. If you see this scenario, 385.440 into 10 power, that means gigabytes of information is uplink data. That is uplink data. Data is transmitted from consumer end. If you see on the other side, the controlling data received from utility center to the consumer, that is 258.64 into 10 power 9, that is gigabytes of information is downlink data. This is the existing infrastructure. But if you do the analysis in proposed, that is decentralized, if you see the picture, if you see the previous picture, here CAS, this is in a centralized way. But if you see here, NASM is having CIS, that is decentralized way. If you see this analysis in this way, what is happening? The entire uplink and downlink is broken. Okay, because what are the information needed for the utility provide the data only, and what time it is needed, that time only it is going to transmit it to the head-end system. The remaining time, all the answers and all the queries are answered by the NASM itself. So what is happening? The the amount of data going to be transferred or going to pulled to the central server is going to be reduced. You see the analysis part in centralized way, consumer to head-end system, 38.44 into 10, sorry, the 10 power, it's not 109, it's 10 power 9 gigabytes. Some error is there. Similarly, that is uplink data. If you see the downlink data, head-end system, see, this is for collective 1 million consumer, not for a single consumer, collective 1 million consumer. For downlink data, that is 403 into 18 into 10 power 9 bytes. That means gigabytes, sorry. Yeah, gigabytes. In a decentralized system, consumer to head-end system, 70.08 into 10 power 9. If you see comparison, huge difference is there. Similarly, head-end system to 1 lakh NASM, because head-end system not directly approaching the consumer in proposed idea. It's approaching the NASM first. From NASM itself, it's going to distribute it. If you're approaching in that way, 3.65 into 10 power 9 bytes, only the downlink data from the central server. The remaining data are sent by the NASM to the 1 million consumer, along with the downlink data received from the central server. So that time 370.18 into 10 power 9 bytes going to be sent. This is for analytic purpose to justify the decentralized system. So this is regarding the two objectives. One is comparative cost analysis. The another one is comparative data traffic analysis. So these are the two outcomes of my proposed work and developed work. Okay. So this, thank you for everyone who for all listening to my explanation. Any doubt from your side, you can ask me.
Hello, madam.
Yeah, yes, sir.
Ma'am, among the you said about LoRa, right? So
Yes.
instead of LoRa, which another have you used any protocol like you were previously talking about IEEE, when before 6-7 months, IEEE 802.15.4. Once you were asking me. So
Sorry,
have
sir.
you
Sorry, sir. I'm not sorry, sir. Can you repeat the question? I'm not able to hear.
Yeah. So around 6 months before, you were talking about IEEE 802.15.4, different type of protocols in a DC meeting. So have you just tried to implement those protocols, or have you used only LoRa?
Only LoRa, sir, because for simulation purpose, while I'm doing on the simulation, I'm stick with the different types of protocols. And also in simulation platform, only Zigbee is available for wireless communication. Some other RFs are there. Because I don't know whether that idea is going to be work out or not. Because of that, one day I used existing simulation communication protocol. But when it comes to implementation, I got the idea from my friends. LoRa is very good for this wireless sensor network. So I choose LoRa for real-time implementation, sir. Hello?
Yeah, okay, ma'am.
Sir, actually, your question is what? Which communication protocol?
Previously, you were talking like IEEE 802.
No, sir. That communication protocol I am not used. Here, I'm used to LoRa communication protocol for real-time implementation, sir.
Okay. Like I think 1 year before you were asking me.
Yeah, sir. After 1 year, the research direction is always going to be updated, right? Because of some negative points we received through the results. So I stick with LoRa nowadays.
Okay, ma'am. And then have you, when you're using LoRaWAN, so Is there anything like, is there any security features? Like, have you changed any bits or any security
No,
features?
sir.
have you
Security features I'm going to add here because, like you already said, privacy is very important when you make a smartness in anything. So still now I completed whether this work is viable and whether that work is it possible to get that optimal cost and traffic results. After that, I'm going to implement some data routing algorithm to the, along with the privacy, encryption and decryption, I'm going to add it in order to make this as a secured communication. So this is that is the next part. So I'm working on that. Once I completed the hardware, I'm going to extend my research on that security.
Yes. So normally we implement 802.15.4. There we used to have two different layers, like physical layer and medium access control layer. So like that MAC layer. Under MAC layer, we used to have the direct sequence spread spectrum coding scheme to transmit information.
Yes,
So
sir.
which, like, even for LoRa also there is some schemes, madam, to transmit information.
Yes, sir. That
Like-
part I need to work it on. So still now I'm working whether this single NASM can able to handle all the meter and can answer all the queries raised by different consumer. Up to that I work completed. So after that, that part is very vast, right? Security, privacy issues. That is totally a different research. So in any case, I have to incorporate the security in my communication protocol. So I'm working on that. So I need to do some research on that particular part, sir.
Yeah, ma'am. For encryption purpose, what have you used, madam? For
I think
encryption,
blockchain technology I can use. Still now I researched some papers. So quantum computing we can blockchain you can incorporate, sir. I think so. From my data collection, I think most of the smart meter papers are involved with blockchain technology along with the decentralized processing.
Yes, ma'am. And also for to avoid the interference between different signals, as you are saying, smart meter, definitely people would like to interfere with that signal and change the values. So have you used any type of schemes, ma'am, to make sure that your signal doesn't interfere with others?
Actually, sir, I'm very happy to answer all the questions, but unfortunately, I'm not working on communication part, sir. That is the thing. Communication is the totally entire thing, because what you are telling, all the points are very, very, very strong point while we are sending the data in a very secure and privacy manner. So I'm not involved in that area still now. So still now I completed with the hardware part only. Whether this work is viable or
understood.
After that only I'm going to add every little bit thing because once the meter is okay, then we can improve all the functionality, privacy, security, then interference, electromagnetic interference. Lot of things are there, sir. I have to work it on little bit later.
Fine, ma'am. Fine, ma'am. And one last doubt, madam. What about this network beaconing, madam? Like, are you implementing that? Like
network
beaconing system, like network beaconing. Nothing like that, no? Network beaconing. Okay,
no, sir. No, sir.
Okay, ma'am. Thank you, ma'am.
Thank you, sir. Thank you. Any other question? Any other question?
I think no questions. We can move on.
Okay, sir. Okay. Thank you, everyone.
Thank you, P. Literacy, ma'am, for sharing your valuable knowledge in smart meter benefits in sustainable smart cities. Next, I will call PS Mahita, ma'am, to speak about the topic on electric vehicles and charging stations in smart cities. Ma'am, welcome, ma'am.
Thank you, sir. Sir, am I audible, sir?
Yes, ma'am, you are audible.
Yes, ma'am, you're audible.
Is the screen clear, sir? Screen viewable, sir?
Yeah, ma'am.
Okay, sir. Thank you, sir. So, welcome to this seminar. I'm now in simulation stage. I have not completed the project yet. I've started with the simulation part.
I'm in the mid of simulation. So I will share the knowledge, whatever I've come across throughout my journey. So the topic is electric vehicle and charging station smart cities. So what is electric vehicle? So vehicle which uses electricity. Okay. See, the vehicles which use petrol and diesel are slowly moving towards vehicles which use electricity. Why it is moving? That is because of the depletion of the fossil fuels like petrol and diesel. So within 20 years or 30 years, we are most probably moving towards electric vehicles only, in spite of all its negative aspects like firing and all sorts of problems. Even though it is still threatening one, still the true fact is that we are moving towards the electric vehicles. So the emerge of EVs in India. See, the electric vehicles have started its presence all over the world. It's moving at a faster pace in the entire world, whereas in India it's slowly emerged, but it's growing in the faster pace. So why we are going towards electrical vehicles, I've already told you, because of its depletion of fossil fuels. In spite of it, we have another important aspect, like it is providing a clean energy. The smoke and the smoke which is given by a petrol and diesel fuels, diesel fuels are all slowly replaced by electric vehicles with clean energy. So we are moving very fastly towards electric vehicles. So we are going towards electric vehicles. So what is very important is the charging station. See, the petrol and diesel vehicles are charged by petrol and diesel in the petrol and diesel bunks. Likewise, the electric vehicles has to be charged by means of charging stations. The charging stations are of two types. They are the fixed charging stations and the mobile charging stations. The fixed charging stations require higher installation cost, and which is why it does not taken its stronger presence in India, because of the lack of space and also the cost. So, but in the developed countries, it's moving at a faster pace. And in India, the mobile charging stations are slowly taking its presence over. It's outpacing the fixed charging stations because of its user friendliness and also the lesser cost. So the what we have come across is, I have chosen the topic development, that is the design and development of movable charging stations in using pushcart. So what is pushcart? Pushcart, you might have seen at the in the roadside used by the roadside vendors. That's for selling vegetables and for selling some idlis or dosas. So what we are proposing is, we are making the pushcart itself as a mobile charging station to charge the electric vehicle, that is particularly two-wheelers only. We are dealing only with two-wheelers. So our main objective is development of multi-generation self-sustainable moving charging station for vendors in local community. That is multi-generation. We are going to use solar panels or wind panels or hand-driven generators for energy generation. So it is multi-generation and self-sustainable moving charging station. Why self-sustainable is, it is going to provide the energy to that is the electricity charge to the electric vehicle, and it is also going to produce the electricity, that is it is going to generate the electricity from nature by means of solar panels or wind generators. So that's why we are calling it a self-sustainable moving charging station. And so the first objective is development of multi-generation self-sustainable moving charging station for vendors and local community. That is for mainly for roadside vendors And the second objective is to reduce the EV two-wheeler charging time by means of intelligent techniques that maintain battery temperature. That is, I'm going to reduce the charge time of the electric two-wheeler by means of some mainly by using the fuzzy logic. So I'm now working on simulation part, which is mainly dealing with the first objective. So I've reached the end of the first objective, and I have to start with the second objective, and the design I have to implement in the hardware part, which is a main criteria for the funded project, which I have asked for in the college, MGR college. So the first thing which I completed is the literature survey. So the main aspect is the completion of the SDG and the SDG 7 and the SDG 13 goals. And mainly the papers have been classified under user survey and performance survey. The user survey, mainly the papers are collected by means of user questionnaire or by means of case study on transformers and workplace charging, where the users mainly charge their vehicles in the workplaces. And the performance survey is the fast, mainly we have categorized under the fast switching efficiency, that is the of the converters which we are using in the for charging the electric vehicle. And the next is standards and regulations which are necessary for using the electric vehicles, and battery modeling, and next is the effect on the grid stability. So these are the criteria which we have used to segregate the papers under the user survey and the performance survey. So the user survey, Purani concluded that hybrid households are accounted for 7 to 15% of the annual vehicle sales. So the hybrid households, it combines both the office and as well as the home. And Bomanak found that users were more open to swapping, but swapping batteries is nothing but instead of charging the batteries, we will be replacing the used batteries with the unused batteries at the charging stations. Then Nicholas discovered that people preferred working at charging at workplace. So in the offices, mainly most of the persons were interested in charging their their vehicles because of the workload which have been pinpointed by Mr. Kanagaraj, which he presented in his presentation. And next is the performance survey. Abdul Rahman emphasized that gallium nitride and silicon carbide were utilized to reduce switching losses, ripples, and increase the converter efficiency. And Grazian concluded safe magnetic field around humans have to be improved with standards and regulations. So safe magnetic field has to be present for the humans who use the electric vehicle. So that has to be included in the standards and the regulations which were formulated. And Bauer explained that dynamic model outperformed the static model as it was easy to extract the battery parameters like SOC, that is state of charge, state of health, etc. And Gong, Lin, and Su surveyed on grid facility. Some stochastic factors were needed. So the grid stability were also taken into account. And Shaukat said the electrification of transformation needed to be done with smart to reduce the carbon levels. And Carl explained the issues of PV on stability of utility grid and method of passive filters. Renewable energy were proposed. So renewable energy like solar panels and wind, likewise we have also proposed. So they have proposed in that paper. And Cartani introduced a parking of car by individual and by car sharing for the car sharing concept that has come in the developed countries. So they will be giving their cars, they'll be parking their cars after which when they are not using, and the users can take the car and they can use it and they can leave their car once they have finished their work, and they can pay the money to the owner. So that is a car sharing concept. And so the fixed charging station. So I have talked about the fixed charging station and the mobile charging station. So fixed charging station. So we have categorized the papers under design, location, siting and charging, planning and optimal model. So the designers, Sharif, designed a solar power charging station and controlled the overall system performance dependent on solar radiation and battery state of charge. So he designed a solar power charging station, and he used the state of charge for charging the electric vehicle, and GAN, there are fast charging EV station with renewable energy and solar charging system. And Tiano did a design and optimization of compressed air storage system with efficiency of 56.7%. And Lanuzi, he analyzed the ultra fast charging station, reduce the charge time to 10 minutes, less than 10 minutes. So he used the ultra fast charging station, he used the DC charging station and he used the grid. And he charged the four-wheelers with lesser than 10 minutes. And next is the location. So Dev Detail, Dev and other authors utilize teaching, learning based optimization algorithm for charging the charging station and reduce the waiting time in the charging station. And Zip achieved an optimized combination of all EV chargers in 2017 and minimize the installation cost and losses. So siting and sizing, this is for locating the charging station and the papers related to sizing of charging stations. So QAng addressed the sizing problem and proposed the explanatory case study. And Nagar STL conducted an optimized charging based method to get the optimized for energy storage of fast charging station. And explorating case study optimize the size and reduce the cost. Planning was like how they planned the charging station and near to the grid, or how it was how many distance it was placed from the grid, and how many expected EV users were there. So Asna performed a case study, achieved user satisfaction, better utilization, and Pazauki considered investment costs and carbon dioxide emissions for optimal planning, and increase in percentage was obtained. And next is the optimal model. So this is a mathematical model and optical allegation of charging station of PHEs were obtained by he and other authors. And Wazifa arrived at the shortest distance for EV users to nearest charging station. That is, the EV users can find out the nearest charging station by means of the net, and they can choose that charging station, and they can also see the queue, that how many users were there, and after knowing that, they can choose the station and they can get charged by means of the fixed charging station. So this was under the fixed charging station, and this is the mobile charging station review. So the mobile charging station is the charging station that will move, and it will satisfy the user satisfaction, and they will go to the user place and they will charge the charging station and get the finance cost. So the S&P et al. Proved the average waiting time of MCS network is lesser than the fixed charging station network, improvement of efficiency of 62%. And Atmaja and Mitanis proposed a concept where waiting time for override MCS reduced by dispatching MCS. That is, the fixed charging station also had the mobile charging station under it, and they were dispatching the mobile charging station under the demand after the demand was obtained, and they will send the mobile charging station to the user place, and they will charge the charging station, and the money will be credited to the fixed charging station. That was the concept. And Akmaja means use the double layer capacitor energy storage by MCS was used to the grid and achieved the efficiency of 95%. And Mogadam revealed the portable charging station at hotspot areas and reduced the waiting time at CS. And Yang et al. Proved global algorithm was better than local algorithm, as global algorithm took charging station queue information into the account. So the portable charging station was something like it was not under fixed charging station. It was a independent one, and the users can talk with the portable charging station, and if it is nearer to the vehicle, then the portable charging station will go to the user, and they'll charge the vehicle and get the money. So that was the concept. So what is our design is to use a push cart as a mobile charging station. So if they're going to sell the vegetables, or they're going to sell the idlis, and this will serve as a side income for them. So they will also have a charging point in the push cart, which will charge the EV two-wheeler within a few minutes, say 30 minutes to 1 hour. And they will get the money for it. So this will serve as a side income for the local vendors. So that is the main idea behind this. And this is mainly for the developing countries like India. And so for the push cart survey questions, we surveyed Indian citizens, and we asked the survey questions were the first question was, do you have knowledge about solar panels and solar energy? So the push cart will be using the solar panels to get the electricity energy from the solar radiation. So this question was asked for the push cart vendors, whether they have knowledge about the solar panels and the solar energy. So what is the specification of the battery? So do they know what is the specification of the battery? Then what is the mode of charging used for the battery? Whether they are charging at home, or they are using for rent, or they are using at in the charging station. Then how frequently do you charge the battery? So they are charging once in a week, or daily, or once in 2 days. And what is the average charging amount per month? So mainly they were telling that the charging amount per month was less than 1,000 rupees. And how much share of earning paid for the electricity? So it is 8% or 10% or 15%. How much they gave the amount for paying the electricity? And what is the total investment of push cart? So how much they got the push cart for, how much amount they are? Mainly they were telling like lesser than 50,000. Then the question we asked was, we are proposing a setup where solar panels are used at the top of push cart. The battery can be used to charge an electric two-wheeler. Do you think this proposal is a good idea to increase revenue? So most of them said yes. So if you see the chart, so I've given the chart for the important questions. So what is the mode of charging used for the battery? Most of them said that they were charging with rent. So they are giving their battery at the end of the day for charging, and paying the money, and they're getting it charged. And next is, what is the average amount per month? So most of them said that the amount of charging amount per month, they were spending around 1,000 rupees. And how frequently they charge was, they said some 62% said that they were charging daily. And when we asked the question, like, we are going to propose a setup where solar panels are going to be placed at the top of push cart, and we are going to charge two-wheeler as a side income for a side income with their they're selling their idlis and vegetables. They said that they were welcoming this idea. So 62%, 68% welcomed the idea. Then when we asked the EV two-wheeler the survey question, so these questions were put forth to the EV two-wheeler users. So why did you opt to own electric two-wheeler? So why did they opt to own electric two-wheeler? So they were asked like whether they were interested or whether they were not they were bugged with using the petrol and diesel vehicles. So those options were put forward. And how much distance do you travel per day? This was a major question that was put. So how many distance they travel per day? How many kilometers? Then what you are aware of the problems associated with electric two-wheelers? Some like more charging time and more frequency of charging and lesser safety precautions and lesser availability of public charging stations. So these were the problems. So these were put forward. And do you use a regeneration resource for charging your e-bike? So they were asked whether they were using the solar panels in their electric two-wheelers for charging the e-bike, and or they are using at home for charging the e-bike with solar panels, and what type of battery they use, like lead-acid battery or lithium-ion battery. And do you think share e-bike should come into such? I've already discussed about e-bike. So we have asked whether they are welcoming the e-bikes, share e-bikes, and what mode of vehicles can be replaced by using like something like whether they can replace cycle or EV two-wheelers like which were using petrol or diesel. We were putting options like that. And how much are you willing to pay at public charging session? How much amount? So for the is it same as the home rent or lesser than the home amount? So the amount that which they pay at home, whether it was lesser than that or same as that or double than that. So we had asked such options. And how much are you willing to pay at a public charging station? So how much amount they are willing to pay at public charging station, and what is the average charging time we are willing to spend while charging EV two-wheeler as public charging? So what is the average charging time? Whether it's 30 minutes or 1 hour or 2 hours. So it was an option put forward. So they chose only the lesser option, so lesser than 1 hour. So would you prefer charging battery rather than swapping it? So there are lesser charging stations if you see the current situation. So we asked some question whether they were interested in swapping the batteries instead of charging the batteries. And so if I see the charts of the important questions, do you think share e-bikes will ship to India? So most of them had responded as yes. And what is the average charging time you're willing to spend while charging EV two-wheelers at public space? They have said that it is lesser than 1 hour or 1 to 2 hours. And what mode of vehicles can be replaced by using e-bike? They've told like petrol or diesel two-wheelers. And if pushcart is equipped with charger, we use the facility to charge EV. So pushcart is if our product is coming into market. So in that case, if your two-wheeler is depleted of the energy, then will you charge the EV two-wheeler with the pushcart as a source for charging? So 92% have said yes. And for the then we ask the survey questions to the public users, that is the public. So so the questions that are put forth were, have you used EV two-wheeler before? So have they used it before as a test ride, or they had rented, or they had not used it? So do you think usage of e-bike changed transport mobility? So do you think whether it has changed the it has moved towards a cleaner environment? So that is the, do you think the usage of e-bike will move towards it? So do you think e-bike is advantageous over petrol or diesel? This question, this was the main question that will see the chat. And what factors would be important if we consider buying an electric two-wheeler? So is it the aesthetic appearance, or is it like how much the EV two-wheeler will charge? That is, how many times it will charge, or how much time it will take to charge with that of the electric two-wheeler, or so those were the factors that were put forward. And how much do you think it would cost to refuel an electric two-wheeler that drove the same number of kilometers that you currently drive in the petrol or diesel vehicles? So if you, this question is something like, if the petrol or diesel vehicles are for 20 rupees, it is going for 10 or 15 kilometers, then for the same 20 rupees, how much kilometers will the EV bike move, go forward? So are you aware that EV two-wheeler can require little or no maintenance except for tires and brakes? So this was asked like whether they know it or not. So it says so, no question. And do you think EV two-wheelers are safe when compared to petrol or with diesel two-wheelers? So this is related to safety precaution, because nowadays one negative effect has come, something like it is burning. So that question we have put forward. Then do you think public charging station would encourage uses of electric two-wheelers? So the public charge, that is the public charging, lesser number of public charging. If you increase the public charging station, will it increase the number of electric two-wheelers? That's the question. That was the idea behind the question. And why do you think that's so much increase in EV sale rate? Is it because of lesser public charging stations, or more frequency of EV charging, or more charging time? So that was the idea behind it. And for the question to use EV two-wheelers, do you use EV two-wheelers? They have said like they have used EV two-wheelers before, and maybe it is a test ride, or they might have bought it from some friend, or they have used it. So they have used it. And why do you think there's so much increase in sale? Majority of them have said like there is lesser availability of public charging stations. That is a main constraint in India. That is because of the lack of space, and also the lesser lack of capital cost, capital expenditure that has to be invested in installing the public charging station. So this would encourage more number of EV mobile charging station. So this is the idea behind why we have chosen the pushcart as EV mobile charging station for charging the EV two-wheeler. And do you think e-bike is advantageous over conventional bikes? So majority of them have said yes, it is advantageous. And so after the survey questions, now I'm in simulation stage. So this is the design behind it. So the top of the pushcart will use the solar panel, and it might use a pedal power generator or hand-driven generator, or they use a windmill depending on the area it serves. And it will use a buck converter with MPPT and it will this will be reduced to 12 volts, and it will store in the DC battery. And this will be connected to the inverter, or it will light an LED bulb that will be as a part of the pushcart itself. And the other other output that comes from the DC battery is it will be boosted to 48 or 72 volts, and then it will charge the EV battery. Now I'm in the simulation stage. So now I've used a buck converter with MPPT, and I'm storing it in the DC battery with 12 volts. And from 12 volts, I'm using a boost converter to boost up to 72 volts, and this will charge the EV two-wheeler. This is because why I'm boosting it to 72 volts is the EV two-wheeler will be uses a lithium-ion battery, and that will be charged by means of constant current charging or constant volt charging or constant current, constant volt charging only. So for that, it has to, so what I have chosen is the current, constant current charging. For that, it has to be boosted to 72 volts. So this is the stage from with which I've completed now. So next I'll be designing the push card, real-time push card for the funded project, and then I'll be working on the research area to reduce the charge time, and then I'll be producing it, and then I'll be simulating it in the hardware environment. So thank you. So any questions? So if there is any question, you can ask me. So any questions?
No, madam.
Okay, sir.
Thank you, PS Mahita ma'am, for sharing your. Ma'am, any questions? No. Thank you, PS Mahita ma'am, for sharing your valuable thoughts in electric vehicles and charging stations in smart cities. Thank you, ma'am.
Thank you, sir.
Dear speakers, can you hear me?
Yes, ma'am.
Dear speakers. Ma'am, Yalil ma'am.
Yes, we are able to hear you.
Sir, actually our event is for 5 hours, sir, but we completed only 4 hours, sir. So let me make one group discussion between you four, sir.
Yes. So you can inform other students, like they can share the thoughts on their projects. Like there are some students in this group, right?
Yeah,
So
sir.
they can like share their own thoughts, what they have done in projects, and what they want to implement in the final year or third year. Okay.
Yeah, okay, sir. Sir, first you four can discuss about what, like example, Element speaks about smart meter benefits in sustainable smart cities. So first you three can share about that, sir. Your thoughts about that.
Yes. You can call. Yes, Elil ma'am can start. You can just speak to Elil ma'am. No?
Elil ma'am, are you there?
Yeah, I'm here. Are you able to hear me?
Yeah, can you hear me?
No, I'm not getting you. Can you repeat it again?
Ma'am, like you four need to do some group discussion, ma'am, about like you speak it about smart meter benefits in sustainable smart cities, right, ma'am? On the topic, what other three are thinking about that and their thoughts.
Okay. Sir, shall we proceed? Shravan sir, Kanaraj sir, and Mahita ma'am.
Yes, ma'am. You can proceed.
Actually, since our idea all are pointing towards the sustainable developments, it's mainly focusing on the sustainable goals, right? Affordable, clean energy. I think my goal is related to SDG 7. What about yours, sir?
Mine is 8, madam.
8.
Mine is SDG 7.
7. What about Kanaraj, sir?
Yes, myself is SDG 7, because I am reducing the peak energy. So the peak energy will be reduced, then the renewable will be incorporated there. So definitely it is going on green environment.
Yes, sir. I think we can collaborate all our research as a single under single platform. Like my project is related to smart meter, and Mahita ma'am project is EV. Since in future, along with renewable energy sources, electric EV is also incorporated in the grid structure. So that metering is also related to that renewable energy incorporation and EV incorporation, and also peak energy management, like Kanagaraj sir objectives also can be considered. So we can make a single idea from all our research, and we can do one common sustainable research. Like we can incorporate all other results as a single in a single platform, and we can deliver some
Yes.
results out of it, right, sir?
Yes, madam. I can correlate it also. I can try in my point of view. I can correlate that. So
Yes, sir.
actually, as a energy management, I need to monitor the energy of the each equipment. So I need a
Yes, sir.
smart
Yes, sir.
meter to track the
Yeah.
values. Yes, in this
I
part,
think,
your smart meter is very important.
Yeah.
Calculate all that. And then your smart meter not only is giving the output, as well as it is sometimes if you want to make a control also, if in future it is also possible.
So mostly your research rely on the smart meter data.
Yes,
right,
based
sir?
on the data. My work is fully related with the data, which is interpreted from your data, right? Based on your data only, I can proceed further, right?
Yes.
But in my point of view, right, in my work, I generally depending on the other two people. Like I need a battery energy storage system to compensate the peak load, and sometimes nowadays the EV also coming into the operation, that whenever we have a electric vehicle in our house, we can use our own energy for during the peak time. We can use it whenever we have off peak. We can charge your electric vehicle. So whenever we have a peak time, we can discharge that one. Okay, we can do it in that way also. So more or less, right, all the work will be correlated with the same SDG coming under the SDG 7 main. Yes, this is my point of view for correlating all our works today. What we discussed, right? It is being correlated in this way.
Yes, sir, the electric vehicle can be charged during the off-peak hours, and during the peak hours it can be made to discharge. So that is the concept behind your peak load management also. Yes, sir.
Yes, ma'am.
Yeah, definitely.
Yes.
Yes, sir.
Recently,
So
many
it comes
articles
to
will
the
be
same
discussed.
platform.
Yes. Because recently,
So,
I read out the many articles, right? These articles are related with that EV mostly. At present, right? EV applications are much in this peak load direction. So mostly in the other countries, they are doing it. So in our India,
Yes, sir,
now only
yes.
the electric vehicles are coming to the operations. Slowly, it may be adopted with the other things.
So everything is relying on the monitoring and controlling, right? The research we are doing now is mostly relying on controlling and monitoring. So definitely we people need to discuss and collaborate the results, what we are getting out of our research, and we can put it in a common platform and give us a separate result for a sustainable environment. I think so, sir. Sir, what about Shravan, sir? Your energy management system, how we can integrate into our one single platform?
Yes, ma'am. So even battery energy storage systems is compulsory as well for Maita Madam project. No?
Yeah,
so Maita is doing on the full carts. So definitely BSS is going to help her. BSS also plays a very important role in smart metering system, as you require something like you require power for those sensors, you require power for the meter, and you want it for a more time, right, ma'am? So definitely it will play a major role in smart meter as well as with Maita ma'am project. So when it comes to Kanakraj sir on energy management, definitely of course in the house there will be some DC loads. So for that DC loads, we can use batteries. So it's going to be useful, ma'am, definitely. And then and then Elil ma'am, like so in your project, like you have used Arduino, right?
Yeah.
So Arduino was used for which purpose, ma'am?
So Arduino for in Arduino I'm taking two categories. One is Mega, another one is Uno. Uno is used for add-on device. That means in order to extract the data from the existing digital meter. Arduino Mega is used for developing the proposed central NASM. So that is the main controller for my proposed work. So two things, sir. One is for Arduino Uno is for Arduino add-on device, and Arduino Mega is for central NASM, sir.
Okay, fine, ma'am. So have you used analog or digital pins, ma'am, for the both of them?
I'm not getting you, sir. What?
Like there are some two different pins, like you know about Arduino that there are some analog pins.
Yeah,
and
yeah,
digital
sir. Analog pins and digital pins are actually when if you are going to see Arduino, if you say take control on the main part along with the controller is input and output. If you are taking input from analog world, then you can use analog pins. Like if you use any sensor, current sensor, voltage sensor, anything in, then the data from that sensor can be fed in analog side. And the digital side, you can get the data that is controlled by programming. You control the data, right? That output can get from the digital side. Sometimes you can get feed the data on the digital side, but you have to do some modification on the programming. So mostly analog is for sensing the sensor value, and digital pin is to deliver the results. What you are done in the manipulation, that result will be reflected on the digital pin, sir.
Yeah, okay, ma'am. Okay, ma'am. Got it, ma'am.
Mhm.
And then, ma'am, so what type of serial communication have you used for sending data from Arduino? Like
More Modbus communication, sending data to digital meter or the NASM, sir?
for GSM, madam.
For NASM, I'm used the LoRa communication. So LoRa is a transmitter in add-on device. One LoRa module acts as the transmitter in add-on device. Another LoRa acts as the receiver and also coordinator in the NASM. So I used 4 LoRa for 4 different houses in add-on devices, and 1 LoRa in NASM device to receive the data as a coordinator and also receiver.
Yes, ma'am. Then how did you configure your bits, ma'am? Like when you're transferring
Yeah.
LoRa, so how did you configure your bits?
Actually, you can program the LoRa as a slave and master device, sir. I programmed the LoRa, each and every LoRa with a separate slave ID. Then while working on central NASM, in that LoRa, I programmed it that way. For this timing, this ID should answer. For this timing, this ID should answer. So in this way, the data will be received through the coordinator, sir. Coordinator actually duty is to coordinate the reception. So we can program it by programming the slave ID, sir. Master and slave ID. If you are programming in that way, you can get the data without interfering another data, sir. Actually, I struggle a lot. Once I'm tried with the 2 meters, it is okay. When I go with the 3 or 4 meters, that time I'm getting some delay.
Yeah,
Some
then,
error data.
yeah,
Some error data.
Yeah, and then how much time it has taken for the data to go from physical layer to MAC layer, madam? Like physical layer to medium access control layer. So how much time it has taken?
Sir, I'm not exactly measure the time, but it's take around 2 minutes or 3 minutes, sir, actually, for all the meters.
So it has not yet reached the application layer. Just to go to from physical layer to MAC layer.
MAC
only,
layer, but reaching that MAC layer is itself taking not actually reaching immediately. But what is the problem is, if you are increasing the nodes with the LoRa, the main problem is data get mismatched. So number of bits collide with each other. So what is happening? Actual data is manipulated and error data will be reflected. So the time to take only reaching the MAC, it is in an optimized way, it takes around 1 minute, sir, 1.5 minutes. Once it started, then there is no problem. Once the slave ID is off, slave is in off condition, that time again we have to wait for that 1 minute, sir.
Yeah, and then is there any sequence number you have kept, madam, for MAC layer?
No, sir. Default, I programmed, actually, I'm not involved the MAC number, sir. I'm just programmed that I mean, LoRa in such a way that it is having one ID.
Okay.
Actually, during transmission, first ID is centered in that byte. Receiver master will check that ID, whether this ID is corresponding to this master or this ID is a slave. First, it check that scenario, I mean, configuration, then only it allows the communication, sir.
Yeah, and then the source pan identifier and destination pan identifier, you put it default, or have you configured it, madam?
Configured, sir. Everything I configured in the program.
Yeah, okay, ma'am. And then what about the payload, madam? Like how much was your payload? Like MAC payload?
No, sir, I'm not focusing on that particular thing.
Yeah,
It's
max
just,
payload is just like how much data is to be sent, like how many bytes of data, like that's
yeah,
a
sir,
frame
I'm,
payload.
yeah, I'm not focusing on, that's why I already told you, sir, I'm not focused on that particular thing, that is communication payload, data loss, data collision, that thing I'm not considered, because the one error I got is data manipulation because of this mismatch in slave ID. I mean, interference between these slaves. I corrected that part, but the point you are mentioning, I have to focus on, sir.
Yeah, okay, ma'am. Okay, ma'am. And then, when you talked about Node MCU, right?
Yes, sir.
So, are you using like there are different protocols? You have heard about MQTT and COAP, madam. Like MQTT is there, and COAP is there.
Sir,
So,
actually, I used the name. I forget it. Suddenly, I forget it. Can you wait for some time and check and tell
yeah,
you?
sure, ma'am. Please check.
Meantime, you can discuss anything, sir.
Yeah. Mahita ma'am is there.
Yeah.
Hello,
Yes,
Mahita
sir.
ma'am.
Yes, sir. Yes, sir.
Yeah, ma'am. Like you can like tell me like I see that pull cart, madam. So what can be the weight of that pull cart, madam? To what weight it can?
Push card, sir.
Yeah, push cart. Yeah, approximate weight.
Approximate is that I haven't come across, sir, but its cost is around lesser than 50,000.
Yeah, cost is less than 40,000. Yeah. So the according like the weight should be known. No? So are you like trying to use? So have you designed any drivetrain model? Normally for my model, I'm designing a drivetrain for my wind turbine. A drivetrain, like the gears are responsible for gear mechanism is responsible for changing the speeds. No? So we some drivetrain model. So is there that drivetrain model in your simulation, madam? How did you design that? Do you have any idea? Because I'm still doing that, the drivetrain model.
The drivetrain, that is because you are going to measure the frequency, no, sir. You're going to you're going to reduce the frequency changes, no, sir. That's why we are.
Yeah. So drivetrain is something where you try to change the speeds, the gear speeds, to changing the gear speed. Like in my case, the wind turbine blades will be rotating very slow, and then the generator will be rotating at a high speed. So to change this, the gear system from slow to fast, I put a drivetrain. So similarly for you also, are you designing any drivetrain?
Sir, we are going to use only solar panel, no, sir, instead of wind turbine.
Yeah.
So we do not need that, sir.
Okay, ma'am. Okay, ma'am. And then last time I was discussing about the charger module, no, TP4056, no, madam. So that one also you're using, like any for lithium ion, normally we use that module only, TP4056 as a charger module. So you're using that, madam.
So still now I haven't come to the PCB mode, sir. I'm just in simulations. I'm going to finish the first objective simulation. That is first what it involved was to use the buck converter from the MPPT module and store it in the DC battery. And from the DC battery, I'm going to use the boost converter to 72 volts, which will charge the EV, that is lithium ion battery with the lithium ion battery with the constant current charging.
Yeah, okay, ma'am.
So I haven't come to the design, hardware design as of now, sir. Only after I finish this, I'll be starting with it.
Yeah, ma'am. Kanakraj, sir. Hello, Kanakraj, sir.
Sir, Kanakraj, sir.
Yes, sir. I'll be here.
Sir, yeah, regarding your energy management, you were talking about Raspberry Pi, no, sir, previously in our DC meeting.
Yes, sir. Raspberry Pi I tried, sir, but I couldn't be able to find out the thing. That's why I skipped that.
Yes, sir.
Yes, sir.
Sir, Shravan, sir, one question, sir. Sir, is there any platform to simulate, like I already said, that Proteus we can simulate virtually the Arduino board, right? Is there any other platform which support full functionality to simulate the virtual concepts of Arduino, sir? Is there any platform?
Yeah, ma'am. So if you want to do, like if you want to connect any type of sensors, like
Mhm.
analog sensor, like if you want to connect any light sensor or gas sensor, and if you want to control LED and AC bulb, there is a platform. Like in your case, you are talking about smart meter, no, madam?
Yes, sir.
Smart meter. So regarding that, no, ma'am, nothing like that. There's no sensor. There's one thing called Tinkercad. So in Tinkercad, you can do the basic sensors. Like
Yes, sir. But the options are very limited, right? The model we can
yes,
use
madam.
setting.
Options are limited,
Ah.
but you will get the entire circuit diagram. The circuit, whatever you are doing there, you will get the circuit diagram.
Automatically the connection will connected, right?
Yeah. No, the circuit diagram, what you do in fritzing, you have learned fritzing, no, madam?
Yes, sir. Yes, sir.
So whatever you do in fritzing, the same
Mhm.
circuit diagram you will get, and also you will get a Gerber file. So you will get a ready-made Gerber file, which you can give it to any G code machine. So in our NGR also college also we may have a G code machine. If you give the Gerber file, you get the G code. So using the G code, you can make your own PCBs. So up to that level, Tinkercad will help.
There is
madam.
no need for personal designing the PCB, right?
Yeah, there's no need for EagleCAD. Normally, we try to design in EagleCAD.
Yeah.
So to avoid that, you can do it in Tinkercad. But in Tinkercad, that possibility is not there. Like your project things are not there.
I know that, sir. Because more optimization we can do in Proteus, because it is nothing but we are building from scratches, right? So in this way, I designed the digital meter in Proteus, a separate model. Then I designed the add-on design, and then I designed the NASM, then I interconnect everything. So it's take a longer time, but is there any platform, because students are in that discussion, if we are having any platform to emulate that Arduino functionality in a virtual way, means it is easy for them to go within more project. That's why I'm asking, sir.
Tinkercad is there, ma'am. If any
Yeah.
students they are interested, we can show now itself, like
Yeah,
how
yeah.
the CAD works. Like if they are interested now, I can
Yeah.
just show them online, like how it works, Tinkercad.
Then
Shall I
we
show
can
them?
ask, we can ask among the participants. If they are showing it us now, we can show it, sir.
Yeah, ma'am, you can ask them, ma'am, like when the
Mhm.
coordinators are like, if they are interested, we can show, madam.
Yeah,
Tinkercad.
sir, sure.
Excuse me, sir. Hari, sir.
Yeah, yes, ma'am.
Sir, even we'll have to fill the certificate, that link, sir.
No, ma'am. Only for
Okay, sir.
participants.
Okay.
Hari,
Yeah, ma'am.
can you ask among the participants if they are really want to know how to do the virtual simulation of Arduino? Then Shravan sir can give a short demo on how to do that on Tinkercad. If the participants are interested, then he will do that demo. Can you ask and
Ma'am, you can ask directly, ma'am. Everyone are here.
everyone?
Everyone can hear, ma'am. You can ask.
Okay, participants, are you able to hear me? Students, if any students are really interested in to know how to do the Arduino projects, not in a real way, I mean, not in hardware way of approaching. If you want to do in a simulation way, then we can give a short demo on how to do that in this virtual platform.
Ma'am, yeah, ma'am. They are interested.
ma'am.
Interested? Okay.
Yes, ma'am.
Sir, Shravan sir, can you share that particular thing, sir?
Yes, ma'am. Yes, ma'am. I'm just logging with my computer. I mean, with my
Yeah,
laptop.
sure, sir.
I'm in
Sure, sir.
mobile. I'll just check. 2 minutes, ma'am.
Yes, sir.
Hello, madam. Are you able to hear me? Hello.
Yes, sir. Yes, sir. I'm able to hear
Yes,
you.
sir, yes, sir.
Yeah, I just. So host disabled, madam. So like you can enable me.
I'm not a host. You just.
Yeah, I'm not able to share the screen.
Oh, Hari, are you here? Are you there?
Sir, can
Yeah,
you
now, yeah, sir. Now he made you as a co-host.
Yeah, okay. So students, you can see here, I hope you are able to see my screen, right?
Yes, sir.
Yeah, so you just type Tinkercad. Just type Tinkercad and you log in with your email ID. It's very simple. And then you have to click new design and then circuits. So if you're interested with 3D printing, then you can go for 3D design. If you're interested with circuits, you can go for circuits. And then here in the search bar, you can take Arduino. Just drag Arduino onto the workspace. So this is your workspace. And then I'll just show you a simple thing how to control a bulb. This is a bulb. And bulb doesn't have any polarity. This is a AC. So just connect any one terminal to the ground for the return path and other terminal to any one of these digital pins. I'm using pin number 7. Then I'm going to go to the code and the code is like scratch programming. So just like blocks, like you have to just take one block and use digital pin 7. So digital pin 7, make it high. And then try to control it. Like I want 1 second on and 1 second off. And this is also in real time, it works the same way. I'll show you the code generated also. So high and low, and then go to the control, just get the weight and click start simulation. Okay, fine. So you can see the bulb is getting on and off. It's not only the bulb, you can just control your TV or a refrigerator, anything with Arduino, you know. And if you want the code which has to be sent into the microcontroller, click blocks plus text. And this is the code, right? I hope this is visible to you. The code is visible, right? Yes, sir. Yeah, this is a code. And if you want to get the circuit, like you want to for a mini project, if you're doing something, you want to show the circuit to your teachers, then you can just click here. This is called schematic view. So schematic view, you get the diagram. Okay. And then you can just click download PDF. So you get it. Okay. So this is the one. And Arduino software is a free software. You can download it from net. Okay. So you can see this is a schematic view. Okay. So I've shown you simple one, but I'll show you real-time projects, which may be useful for your mini project. If you're interested with mini projects, so you can do that. So like just go to the circuits again. So go to the search bar and type Arduino. So drag this Arduino onto the workspace. So I'll show you motion detection system. Okay. So PIR. So this is passive infrared sensor. And this sensor is just cuts for 100 rupees in anywhere in Chennai or any place. Just try to rotate this. It's got 3 terminals. So one is signal, power and ground. So power, you connect it to 5 volts. So this is Arduino. These are the digital pins. These are the analog pins. These are the power pins. So always connect power to 5 volts. Normally all sensors we give 5 volts. It's very simple. And then you have the ground. Ground. So please connect it to the ground, which will give you the return path. Okay. Fine. And then you have this is signal. So any one of these, like now you can connect it to digital. So you just connect it to digital because we just want to know 2 things, whether anyone is detected or not. Okay. If you want to have more than 2 values, you go for analog. Digital means it's always binary, either 0 or 1. That's it. So this is your circuit. And if a person is detected, I want a bulb to glow. So just take bulb. So normally in real life, if you want to connect bulb, please use relay. Because Arduino doesn't work on 230, it works on 5 volts. So you have to use a relay. Okay. So just connect one terminal to the ground. Another terminal is just connected to any one of these digital pins. So I'm going to use pin number 4. Okay. And you can put different colors. Now, how this works, click start simulation and first see how the motion sensor works. So just click on top of this so you can see here. Okay, this is the range. And if you just try to move in the range, the Arduino will detect and will switch on the bulb. So for that, we have to do the program. So see the program, it's very simple. just remove all these blocks. So create a variable. So variable you have seen in C language. No? Variable is something where you just store the data. So click create variable, just give some name, like I'll give some name as sensor, any name you can give. Okay, so get the sensor to and put some data. So what data it has to be, like the data coming from the sensor. So go to the input and take read digital pin option and see where your pin is connected. Like this is connected to pin number 7. The sensor is connected to pin number 7. So take pin number 7. Okay. And then you have to go to the control and get a if else loop. So you have an if else loop here. Then go to the math and get the less than operator. So make this as equal to. So if motion is detected, right? So go to the variable, get your variable. So if motion is detected, I want the bulb to turn on. So if you want the bulb to turn on, as Elin ma'am said, you're always going to connect to the digital pins. If you want to something, if you want to make a turn on operation. So get the set pin option. So just see where the bulb is. So bulb is at pin number 4, make it high, or else make it low if there is no detection. So it's very, very simple. And this thing you can make it for a mini project. Like instead of using bulb, you can use bulb, you can use LED, you can try to switch on some type of loads. Even you can turn on a very big load like AC, refrigerator also you can turn on depending upon the temperature. You can design a mini project for in your house. You can turn on your refrigerator, turn off your refrigerator depending upon the temperature. Okay, or your air conditioning unit also you can control. Fine. So that's it. So the program is very simple. Just click start simulation and I'll show you the results. Okay. Just move this. And students, you can do it in real time. It works in real time. It's not only that it's working in simulation. A Tinkercad, it will even work in the real time. Okay. I've done many projects. It will work in real time. Just try to move this, the bulb on. So real time, whenever some person is there, just whenever some person is there, just forward near to this motion sensor. If there is any detection, it automatically senses and it will instruct to turn on either light or fan or whatever it may be. Okay. And again, you see here the schematic. So if you click schematic, you will get the diagram. Okay. Fine. So have you understood this? Like, shall I teach you the node MCU part? Like ma'am was talking about node MCU. The node MCU also can be done in another software, easy to code software. Node MCU is about IoT. So shall I teach that? If you're interested, go for node MCU. This is the basic thing. Okay, fine. So this thing, I hope you guys can do this. Okay. So Elil ma'am, shall we go for that node MCU?
Yeah, sir. Yeah, sir. Sure, sir.
Yeah. Okay. So after this, I'll show you node MCU. For node MCU, you have easy coding. Okay. So easycoding.tn. So all you have to do is just type easycoding.tn. Yeah. Okay. This is easy coding. So here you can learn Python. So here with Node MCU you can learn Python. With Raspberry Pi you can do Python, and you can do motion detection. You can learn OpenCV. You can learn Python with data science. So along with microcontrollers. So this is for, like, I'll show you how many it supports. So this is Node MCU. Just 1 second. Yeah, to know it for ESP8266 and ESP32. So I hope you have heard about ESP32. There are Node MCU is ESP8266. Okay, this is ESP32. So you can do programming for ESP32 and Python. Python is Raspberry Pi. So if you want to learn Raspberry Pi, you can learn it with Python. So I'm trying for Node MCU. So I'll click this to know it for ESP8266. Okay, so Python programming, including artificial intelligence, OpenCV, and Raspberry Pi. Okay, that's it. Fine. So I hope you got this. I hope my screen is visible to you, right? Got this? It's visible, no? Okay, fine. So yeah, this is Node MCU programming. Like here, what we do with Node MCU is, I'll show you the different cloud platforms. So you are maybe some of them who have little bit who know about IoT, you would have heard about the ThinkSpeak and IFTTT. So these are there. So you can click IoT. So under IoT, so you have ThinkSpeak. Okay, so this is entire thing about the cloud platforms. So if you are interested in programming Node MCU, if you want to interface Node MCU with the cloud platforms, so this is ThinkSpeak. Okay, so you have all ThinkSpeak related, and also you have CAN, so web services. So CAYENN. So yeah, this is IFTTT. This is another IFTTT. IFTTT is also web service. So any student want to do any like live with me, IFTTT. It will reflect in your mobile phones. Like you want to do any one cloud service, IFTTT live. I mean, along with me, you want to do. Anyone is interested? All you require is a mobile phone. You have a mobile phone and don't need a laptop. If you have a mobile phone and if you're interested to do one live cloud project, I'll just show you. It just takes 10 minutes, 5 minutes. Anyone is interested?
Yes, sir. Yes, sir. I'm interested.
Okay, fine.
Yes, sir.
Interested? Okay, fine. So you open your mobile phone, go to the Play Store. Okay, just go to the Play Store in your mobile phone. Okay, so have you gone to your Play Store?
Yes, sir.
And then type IFTTT. Okay, I'll show you my screen. IFTTT. This is IFTTT. It's a cloud platform. If then this that. IFTTT.
Sir, we can get any demo video for this particular platform in YouTube or any other sources, because if students want to learn something out of it, this intro can help you a lot, help them a lot. But if they want to learn something from
Yeah,
any
ma'am.
YouTube
Actually, madam, there is a lot of information in YouTube. All
yeah.
They have to have some patience and they have to have the eager to learn. But there are huge things.
Any particular playlist, sir? YouTube playlist,
No,
any particular channel you referring?
Ma'am, normally, like currently, I'm not doing this. Currently, I'm doing Selenium, but
Okay,
I don't remember if they type in YouTube. There are some thousands, ma'am. They can follow anything.
Yeah. Okay.
In Tamil also, it's there in Tamil.
Yeah.
It's
Yeah.
there in Tamil also.
Okay, sir.
So I hope you have you got into the Play Store?
Sir?
Yes, sir.
Have you got into? No, I'm asking the student, madam. Have you
yeah.
got,
Yes,
sir. Yes, sir.
yeah, IFTTT.
Yes, sir.
Are you able to install that?
Yes, sir. We installed it. 1 minute, sir. It's downloading.
Okay.
Student, please mute yourself if you are with a noise environment.
Fine. So this is the IFTTT website. So everything works better together. So you will just combine all type of sensor, as Ellen ma'am was talking about sensors and IoT. So normally we can use IFTTT. So just click login and you can just use any of your email ID. Like I'll use. Wait. Because you receive some advertisements, I'm not using my regular email. So log in. Oh. Okay. So,
no issues, sir. No issues, sir. You just give the intro of IFFT because you are logging with a lot of platforms, so definitely something.
Yeah. I'll just use my normal.
Okay, sir. No issues there. Or is there any tab with sign in with Google?
Yeah. One of the students is. Yeah, got it, ma'am. Got it. Yeah,
got it.
Fine.
Okay. Fine.
So I have just logged into this.
But sir, it's asking free.
So I hope anyone has logged into IFTTT.
Yes, sir.
Yeah, sir, I'm logged. But it's asking premium, sir.
Sir, that Gabai is asking about Selenium, sir. You are talking about that Selenium courses, right? He's asking about.
Yeah. So what I do with Selenium is actually I try to interface the Node MC with Selenium. So my goal is if I send one SMS to any particular number, it will book my ticket from Hyderabad to Chennai, and the payment will be done through the Pay ATM. Automatically, it will be debited, and I'll get a confirmation message that my ticket is booked. Okay, not only this ticket. So I use Selenium for automation. Like if I want, if I'm interested in tickets, like the movie tickets. If I want to book movie ticket, or if I want something from Big Bazaar or Ratnadeep. I just
Mm-hmm.
I just put one SMS or just send one email. I'll just send one email through IFDD. The
Mhm.
email automatically activates the Ratnadeep store, or it may be any other store, and it will just book whatever in the cart. It's going to be in the AWS side, Amazon, the Amazon
Okay.
site. I'll just go to
Okay.
the cart, and automatically it will push all the contents in the cart. It will pay the bill, and I will receive the material to my house without any interference. So my interference will be just
Okay,
I'll put an email like I need so and so, like I need 10 kg sugar and one this one and some fruits and vegetables, and just send that. And the system helps me in automating things. And in between there is a node MCU. So node MCU will send the data to the cloud. Like there are two things, ma'am. Like one is the fog computing, other one is the edge. Fog and
Okay.
edge. So automatically the information moves away, and Selenium helps in programming. So shall I show you one Selenium program? Anyone interested?
Yes, sure, we are interested.
Okay, but have you done this IFDD? You are able to log in IFDD. One program will complete.
Yeah, sure.
Okay, I'll just show you how to create an applet. Then we'll see Selenium also. Meanwhile, I'll just show you. So, ma'am, my screen is visible to you, ma'am. Hello, Elaine, ma'am. My screen.
Sir. Yeah, visible, sir. Visible,
Yeah,
sir.
so just click create. Okay, you have to just click create. Yes. So if just 1 second. So these are my applets. So I've created many applets. I have to just delete any one of them. To make one. So it's only giving 5 of the app, 5 free service. So I have to delete any one service so that I can show you. So
it's a paid one, right? After 5, you have to pay.
After 5, so only allowed 5. So I'll create one, madam. Like
okay.
So if you have to choose one service, I have choose date and time. Okay. So date and time. So date and time, I'm going to set something like every day. So now the time is like 9:45. I'll set it for 10 p.m. Okay. So just go there and just click here and select 10 p.m. Okay. So every day at 10 p.m. So something is going to happen. So what is that something? It depends. Like that something maybe to call somebody, to make one phone call to somebody automatically. To send some message in Twitter, or to send some message in Insta, to send some message in Facebook. Okay, it can be something. Like I'll trigger an email to me. So I'll just put email. This is Facebook. You can see the system, ma'am. Like how many applications? Like you have Facebook and Insta. Show you Insta. So this is Instagram. Yeah, Insta paper is there. Fine. I'll put one email. So every day at 10 p.m.
10 o'clock. Okay.
I need an email. So 10 p.m. Like send me an email. Okay. So what is the subject of the email? Like I'll say something like today is a holiday, or tomorrow I should tomorrow. Yeah, I should work hard. Okay, something like that. Anything. And then body. So body means the content of the email. You put whatever you like hi and whatever message, and create action. That's all. Okay. So done. So every day at 10 p.m. I'll get this email. It's very simple.
Okay. This is this is similar to the Apple shortcuts. In Apple shortcuts, we can create automations like that.
Yeah, ma'am. But this I'm able to combine with Node MCU. That is a good thing.
Yeah.
Here,
Okay.
I will combine with Node MCU, and I'll show you the IFDD here. So this is Tenoid code, and you can see, ma'am, I can see my screen here, IFDD. Here there are different events, right? There's a Facebook.
Okay.
Just type the event, type the key, and connect this to Node MCU.
Okay. So we can customize.
Yeah, we can customize. Okay, that's an advantage. This looks very simple, but even if you do it through coding, like through blocks, it's even more simple. So anyone has created one applet?
Students, anyone?
So meanwhile, I'll also show you Selenium. Yeah. So you have completed the applet?
Sir, did not complete it, but
Okay. Just try. But you know the process, right? Just click create.
now we create only, na there.
So you can just click create here, and then you'll get it, applet. Okay. So I'll show you the Selenium also. Just opening Eclipse IDE. So we do it in Eclipse IDE, Java programming. So ma'am, even this Eclipse, I am trying to interface with NodeMCU. So Ellen ma'am, you heard
Okay.
now Eclipse.
Okay,
Yeah,
okay,
Eclipse.
okay, okay.
Eclipse is for Java.
Mhm.
Show you this. And then for Raspberry Pi, we do in AWS. There is one AWS service is there for Raspberry Pi simulation.
Mhm.
There you can do. Yeah, just
Okay.
like this Tutunoid code, Raspberry
Mhm.
Pi, we do it in AWS. Just 1 second. I'm just showing you the Selenium code. Just opening. Yeah. Okay. So I'll take one. You can see my screen, right?
Yeah, sir.
Yeah. I'll just take one program. Yeah. This is a very simple program which just opens the browsers. That's it. So
Mhm.
not show you the Amazon one. It takes time. Yeah, only after 10 minutes.
Yeah,
So
sir. For demo, it's very
yeah, it's
easy
just
to
like the
understand.
way I've shown the Tinkercad art, I'll just open it. So anyone who wants to do the IFTTT, they can tell me. IFTTT. I hope you have created at least one applet. If you have any doubts, you can tell me. And you can use Insta also, Insta, Facebook, Twitter. Just initializing. Yeah, so this is the code. Like this is the code, like it just opens Google, waits for 3 seconds, and then Google gets quitted up through Chrome. And then one more time, I'm going to open Google through Firefox. One more time, I'm going to open Google through Edge driver. Okay.
Okay.
Very simple. Yeah, very simple. This contains of 3 different browsers. So I'll just click here, right click and click run as Java application. That's it. Okay. All I require is some internet connection. So it will launch browsers. And the coding is very similar to C language. So initially it may take you some time, but it's very easy to learn. So automatically this will initialize the browsers. Just I have to make sure I have the internet connection properly. Our home driver has started successfully. So you can see here.
Firebox and Edge, so it takes some time to load
Yeah,
each and
1
everything.
to 3 seconds, ma'am. That's it.
Yeah, we can reduce the time also, right?
We can reduce, ma'am. If
Okay.
I'm in a good, yeah, so you can see these.
Yeah.
It is open and so it opens and it automatically quits. So
Okay.
automatically it just quits. So, okay, and then it opens the Firefox.
So how we are writing our program in that way, it's working.
Yeah.
Okay.
So it just opens the Firefox to see. No, it's still maybe, yeah, red port, just finding the ports. You can see this commands here. If I open this here, now you can see, ma'am. Like
Yeah.
right,
Port is opening. Okay.
yeah, port is opening.
Listening on WS. Okay.
Check.
Failed to fetch.
Yeah, some
Some
certificate.
error. Yeah.
But it just opened. Yeah. Now it's empty. I think it's just open. Yeah, it's open, ma'am. So it's open and it's going to automatically type in Google. So it just takes some time. Now it's typing Google.
Yeah. It changed to Google.
Waits. Yeah, it just waits for some 3 seconds according to the program. 2 to 3 seconds and it automatically quits. So you have to just wait. It automatically quits. Yeah, it just got quit. And then we have the Edge. So
Edge, Microsoft Edge.
This is the Edge. It's not yet open still. Yeah, so you can see here, it's just like Edge driver, it's trying to initiate opening browsers. These are the commands. Once, just wait for some time. So it will automatically update. Normally what happens, the Chrome browsers have to be or automatically updated every 1 week. So here there is a command where we try to automatically update our Chrome drivers to avoid errors. Chrome driver and maybe it's taking some time. It's not yet open.
I think it's already opened because of that. I think it's having some.
Yeah, maybe I have to still wait. Okay. Maybe some error is there with, I
Yeah,
have
yeah,
not
sir.
updated something like
Okay,
that.
sir. Okay,
So
sir.
this is the
It's-
basic thing,
Yeah.
selenium.
Mhm.
Fine. That's it, ma'am. And IFSSS, if anyone wants, like I'll tell you. Okay.
Okay, sir.
Yeah. if
Thank you for
anyone-
sharing your information among the participants. And also we learned a lot of things from your side, sir.
Thank you.
Thank you for your effort. I think we can hand over the session to Hari. Hari, are you there?
Yeah, yes, ma'am.
Yeah, yeah.
Thank you all. Thank you, speakers. Now I would like to call our chief guest, Dr. J. Balamurugan, sir, Honorable Secretary of IIA Tiruvallur Local Center, to conclude the event.
Yes, thank you so much, Hari. So it was an excellent session, and I could see that people not only have provided the insight of their own ideas of their thesis, but they also showcased the practical application and how it could be implemented. So this is the way it is going to be sustainable. So I could also see the kids who are kids means I mean to say the participants who are listening. So these scholars were giving like a mammoth task, and how could I achieve it? So that was the myth they had. But still, after showing such applications, so though it has made them understand that it is as simple as it is, and when we go on a precision, so like say we would get in depth of such matters, so we could go beyond that also. So that is the sustainability. So that's how the younger generations also can pick up this technology. So technology transferring is something like all these scholars have given an input on sustainability, so which is going to be the seedling for the next generation. So hats off to the entire team. So I personally thank all such peoples, Mahita, Kanagaraj, Sharwan, Yeril, and other people who have participated. And I also thank all the participants who have given their timing and dedication for learning such things. And it is a good opportunity for all such people to learn the new technology resources. Thank you so much. And I also thank Hari so for making the event more successful in organizing and making all such events. So thank you, the entire team. So I also like to invite all the people for participating in the 100th year. So 100-year celebration is going to be conducted by Institution of Engineers by December 15, 16, 17, and 18. So it could be the starting point is the celebration event on 15th, followed by Indian Engineering Congress, which is renowned event that is every year it would be that is celebrated on the same day. So December 16, 17, 18. So that's how it is being celebrated for this year. Right now, it is going to be conducted in Chennai. So every year it would be circulated among the 4 metropolitan cities or the centers. Around 125 centers are there in India. So like all these centers would be celebrating it, and now we have the opportunity to mingle with all the technographs. A lot of seminars and other symposiums would be conducted there. And we also going to give this centenary event. This centenary video is going to be broadcasted and telecasted on this event. And moreover, additional point is something like in the IEC, so the president or prime minister would be the chief guest. So yet to be confirmed. So once it is confirmed, we have the opportunity to mingle with all such people in Chennai itself. I also welcome all the people to participate as a delegate. So thank you so much for your participation. Thank you. Thank you, Hari.
Thank you,
Thank you.
sir.
Thank you, sir.
Now I would like to welcome Sayed to give the vote of thanks.
Thank you, Hari, for giving the opportunity to deliver the vote of thanks. It gives me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. I would like to thank our chief guest, Mr. Balamurugan sir, who honored this function with his inspiration thoughts. I would like to thank our beloved speakers and participants making this function a grand success. Once again, I thanks one and all present here. Thank you. Thank you, everyone.
Thank you. Thank you.
Thank you.
Thank you, Hari.
Yeah, thank you. I can leave the meet now.
Hari, can we leave?
Yes, ma'am.
Yes, ma. You can leave and you can stop the live, Hari. So you are waiting for 4 minutes to count down, or you are closing the live. Okay. Anyhow, people
Yeah,
can
okay, sir.
leave.
I will close
People
it.
can leave. You can stop the live and you can close the event. Okay, ma.
5,
Thank you.
4, 3, 2,